This is Earth, 335 million years ago. I wasn't around then, but there's just one supercontinent, Pangaea. See? Let's watch it shift around and fast forward. Okay, here we go. It just split into two huge pieces. Australia goes this way, North and South America go that way. Africa, Asia, Europe, forming, and there we go. The planet as it is today. Let's keep going. I mean, the continents are always on the move. Over time, some of them will crash into each other. Others will break apart. But that'll take about 100 million years. Better put it on super fast forward. 100 years from now, humans keep spitting carbon dioxide into the atmosphere, and the planet's already warmed up a bunch. The world's ocean levels have risen about 4 feet. The Bahamas? They've totally disappeared. 200 years from now, the Earth's population is about 19 billion people. The climate's gotten even warmer. We're packed in like sardines over here. New medical tech makes it possible to live to 180. But why? Fossil fuel reserves of oil and gas? Long gone. Oh, and the continents have drifted over 16 feet. The Voyager 1 space probe's about to enter an asteroid cloud at the edge of the solar system. It's the most distant man-made object in the universe, I guess. 1,000 years from now, thanks to better quality food, humans are now 7 feet tall on average. Technology solved the pollution and fuel shortage problem. Humanity's doing just fine. Robots do all the work, we just play around all day. Ocean levels have crept up another 10 feet. Islands like the Seychelles, Maldives, Galapagos, and many others have gone underwater. Denmark, the Netherlands, Eastern England, Thailand, and Vietnam are only partially underwater. There's been a huge human migration these last 100 years. Fast forward about 5,000 more years, and it's the year 8113. Humanity's getting ready to open the crypt of civilization. It's a hermetically sealed room in Georgia, in the States. Bad Georgia. It was created in 1940, and it's full of about 800 books on microfilm, recordings of famous people's voices. It's also filled with bits of technology from that time, like a toaster, a radio, and a typewriter. Some awesome people created the crypt of civilization in case humans experienced a major catastrophe in the distant future and had to rebuild civilization from scratch. We'd all go back to using typewriters. 15,000 years from now, our planet has changed its tilt, and the Sahara Desert is now a tropical paradise. Years of rain turn the dry desert into a wild jungle. 30,000 years from now, the Voyager 1 space probe has finally left the asteroid cloud at the edge of our solar system. If it doesn't collide with anything, it'll be flying in the dark, wide-open outer space for a very long time. 50,000 years from now, the climate's changing a lot. The temperature on Earth is beginning to drop, and we are approaching the beginning of a new ice age. The radio signal with a special "Hello, all you aliens out there" message sent into space in 1974 has reached its destination. The message contained the human number system and data about our DNA and our solar system. If there was someone on the other end to receive this signal, we might have a response from them. 100,000 years from now, one of the largest known stars in our galaxy, Canis Majoris, explodes with enormous force. The explosion of this supernova can be seen from Earth, even during the day, and the nights are much brighter because of the new strong glow in the night sky. What's new on Earth? Supervolcanoes start erupting all over. These volcanoes spew colossal amounts of lava and ash everywhere. Thick black clouds cover most of the sky. This prevents the sun's rays from reaching the ground, and the temperature on our planet drops even lower. Humans mostly live underground anyway, so it's no big deal. Because the stars are gradually moving in different directions, the usual constellations are starting to change shape. Soon, we'll need to come up with totally new constellation names. 250 years from now. Oh, a new island's on the map. Back in 2021, it was just an underwater volcano somewhere in the Pacific. After thousands of years of spouting out lava, it finally reached the ocean surface and busted out in the cool, fresh air. Not much growing on it yet. Niagara Falls has long since disappeared, and Lake Erie and Lake Ontario have teamed up to form one huge super lake. 300,000 years from now, the triple star system WR104 is about to explode. It's spinning crazy fast, and there's a chance that radiation from the explosion could eventually reach Earth. That would do a lot of damage to all life on our planet. Voyager 1 reaches the brightest star in the night sky, Sirius. Not a very funny star at all, it's really Sirius. It's 8.6 light-years from Earth. 500,000 years from now, scientists are pretty sure that a huge meteorite could fall to Earth any day now. It might be even the size of 8 football fields. The impact of such a massive meteorite would cause an explosion so powerful that its sound would be heard on every continent. That would be followed by super strong earthquakes and tsunamis higher than the Brightside Empire municipal building tower thingy. Okay, I just made that up, but who knows what we'll be building in the future. 1 million years from now, the rogue star Gliese 710 comes very close to our solar system. We're surrounded by a huge shield of asteroids called the Oort cloud, and the rogue star is beginning to affect the asteroids hanging out in there. It grabs them, spins them around, and throws them toward the center of our solar system. Comets start to fall on our planet all the time, big ones, causing more tsunamis and earthquakes. 10 million years from now, the Red Sea is gradually expanding into the East African Rift. Africa is now divided in two by a new oceanic gulf. The human DNA molecule has completely decomposed. But it's no big deal. We've become totally digital, without any pesky aging problems. The really cool thing is that other animals have evolved a lot and changed ridiculously. Thanks to a simple interface, we're actually able to talk to dolphins, chimps, dogs, and cats. Turns out cats aren't grumpy, they're just busy contemplating life. 25 million years from now. The San Andreas Fault has been crazy recently and has caused the Gulf of California to flood the Central Valley. There's a new sea on the west coast of North America. 50 million years from now, Africa just collided with Eurasia. The Mediterranean Sea is totally gone. There's a new tallest mountain in the world. Its name? Mount Everest, of course. Australia is continuing its journey north. It already collided with Southeast Asia a few million years ago. The few human colonies still left on Mars need to do some serious packing. Phobos, one of Mars' moons, is beginning to orbit at a lower and lower altitude. That's not good. It's about 14 miles wide, so that's going to be unpleasant. 60 million years from now, the Canadian Rocky Mountains have completely eroded. It's just one gigantic flat plain. 80 million years from now, all that remains of Hawaii is one island. All the others have long since gone underwater. But just next door, a whole new chain of Hawaiian islands has emerged. Finally, 100 million years from now, we made it! The Atlantic's shrinking down to nothing. The Americas are almost rubbing up against Africa. Africa's already merged with Eurasia. We've got ourselves a supercontinent again. Hello, Pangaea Proxima. All traces of human life are gone or buried deep underground. The movement of the continents has destroyed tunnels, roads, buildings, bridges. Animals and plants now reign supreme on Earth. So, where are all the humans? Well, remember we made the jump to digital about 90 million years ago? Things are still going strong. There are trillions of human minds living on a huge hard drive on a spaceship orbiting Earth. The super low space temperature is good for keeping the drive nice and cool. We have millions of different societies, languages, and cultures, just like we had 100 million years ago. The only difference? We're all little ones and zeros in a huge digital universe that we created. And yes, there's still football. So scientists have this idea that some exoplanets, which are worlds outside our solar system, might be water worlds. They orbit their distant stars, covered by global oceans. Even better, some experts claim that our Earth was once the same, a vast expanse of the ocean, and just a bit, if any, visible dry land. At the moment, water makes up 71% of Earth's surface. Our planet experiences continuous movement of water. First, water evaporates, rising from the ocean surface to the atmosphere. Then rains fill lakes, rivers, and underwater reservoirs. Eventually, all this water ends up in the ocean again. Water also plays an extremely important role in the processes happening below the ground. For instance, water content in magma determines how explosive a volcano can be. Anyway, one of the most burning questions about Earth's water is, where did it all come from? It's very unlikely that our planet was simply born this way. The thing is, water has a way lower condensation temperature than some other substances, like silicates or iron. These materials compose the terrestrial planets in the solar system. In the early history of our planetary system, the region where Earth formed was too hot for the oceans to condense at the same time as our planet appeared. So, there's this idea that water appeared on Earth when melted meteorites hit the surface of our planets. Well, scientists disagree. Researchers analyzed some melted meteorites that had been hanging around in space since the formation of the solar system about 4.5 billion years ago. They discovered that those space rocks had extremely low water content. Even more surprising, they were among the driest extraterrestrial materials ever found and examined. In other words, once they melted, there was essentially no water left. These results were very important, since they helped scientists rule out melted meteorites as the primary source of water on Earth. Plus, we can say that this revelation was kind of eye-opening. Imagine the unlikely conditions that aligned to make our planet habitable. Getting water and developing surface oceans on a planet so small and so close to the Sun is a great challenge. If Earth had formed just a tiny bit closer to the Sun, our planet would have been much hotter, and all the water would have most likely evaporated. If it had been farther away from our star, Earth would have turned out to be much colder, and the water would have probably frozen into ice. The team of scientists managed to analyze 7 melted meteorites that had crashed into Earth. Those must have splintered from at least 5 space objects known as planetesimals that later collided to form the planets in our solar system. These planetesimals took part in something known as melting. They got heated up as a result of the decay of radioactive elements in the early solar system. This caused them to separate into layers with a core, mantle, and crust. Plus, the heating and melting of planetesimals apparently led to near-total water loss, regardless of how much water they started with. As for meteorites, some of the samples arrive from the inner solar system where our planet is located. The conditions here are relatively warm and dry, so it's no wonder the meteorite samples didn't contain much water. But a few samples were from the colder outer reaches of the solar system. That's from where the water is believed to have come to our planet. But if this water hadn't been delivered by meteorites, what kinds of objects could have carried it all the way across our planetary system? There's one more theory, though, that hydrogen inside our planet played an important role in the formation of the oceans. At the same time, these two ideas are not mutually exclusive. Water could have been delivered to Earth by impacts from some space bodies, like asteroids from the outer edges of the asteroid belt, spanning between the orbits of Mars and Jupiter. And some amount could also appear inside our planet. There's also a theory that claims that Earth gradually grew by accumulating icy planetesimals about 4.5 billion years ago. At that time, it was still only 60 to 90% of its current size. According to this theory, Earth managed to retain a certain amount of water in some form throughout the process of accumulating its mass, and as a result of large impact events. It sounds quite plausible. The examination of the chemical composition of lunar samples brought to Earth by the Apollo 15 and 17 missions indicated that water had already been present on our planet before the Moon was formed. So far, all these ideas remain just theories. At the moment, we don't know for sure how water appeared on Earth. What we do know is that there are many other space bodies that have water in this or that state on their surface, or under it. Let's start with our dear Moon. On Earth's natural satellite, water can be found all over the surface, but it's probably not the water you imagine. You won't find pools of liquid water there. On the Moon, it's mostly ice. Some places have more water than others. For example, the poles of the Moon are regions that never get any sunlight. That's why they're extremely cold, and there's a lot of ice there. Plus, the ice in these areas is often mixed with the lunar soil and hidden deep below the surface. Then there's Jupiter's moon Europa. Astronomers consider this world to be one of the most promising places in the solar system to search for new life forms, all because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, the temperature, pressure, and chemistry are far different on Europa. Scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water reservoirs on Europa are, or how long they need to refreeze. Enceladus is the sixth largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. Wait, we should try that. Never mind. When the Cassini space probe first arrived at Saturn, astronomers thought that Enceladus was going to be a frozen ball of ice. But then they saw plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a massive ocean between the moon's rocky core and its icy shell. If you've been imagining Mars as an extremely dry place, you need to listen to this. Scientists think there could have been a lot of water on Mars in the past. What makes them think so? They found lots of ancient river valley networks and lake beds on the surface of the red planet. Plus, on Mars, there are minerals and rocks that can only form in liquid water. Mars might even have experienced terrible floods 3.5 billion years ago. These days, there's still some water on the red planet. It's true that Mars's atmosphere is too thin for this water to stay in its liquid form on the surface of the planet. But under the surface, it's a different matter. You can find water in Mars's polar regions, but the only place where this water is visible is at the North Polar Ice Cap. Sometimes salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. Since we know for sure there is liquid water on Mars, could we possibly use this water during the human-operated mission to the Red Planet? If we manage to do it, spaceships coming from Earth wouldn't have to bring their own water. It would make the cargo way lighter, which, in turn, would decrease the cost of the mission. We would just need to take enough water to get to the Red Planet and bring along the equipment needed for filtering Martian water to make it drinkable. Well, it sounds simple enough. You're in the middle of the Sahara. You see a huge awning with a red target pattern. Its surface is so hot you could fry food on it. A drop of water is to hit the center of this target at the speed of light. Theoretically and technically, this experiment is impossible to conduct. But if it happens, then mysterious nothing awaits us. And each version of this nothing will be different. So we'll do 3 drops. Option 1. It's better to do it from a great height or space. You take off on a jetpack into the stratosphere. You have a bottle of water in your hand. You pour out 1 drop. Let's say it starts accelerating itself. In this case, even at a low speed, a drop of water will burn up in the protective layers of the atmosphere. In less than a second, the drop will turn to vapor. Let's say our planet had no such protection as the atmosphere. The air resistance would still get rid of the drop. The drop is flying down at a tremendous speed. The cold wind turns it into an icicle. The greater the drop velocity is, the stronger the air resistance is. The drop is moving faster and faster, soon reaching the speed of sound. Then, it just smashes into thousands of small particles. Under such conditions, the drop will never be able to reach the Earth at the speed of light. Nothing happens because nothing gets to the target. The next attempt involves changing the drop. Oxygen, carbon dioxide, ozone, and other gases in the atmosphere destroy any falling object. But what if the drop didn't meet all these obstacles? You change the internal structure of water chemically. So, you put your jetpack on again and grab a bottle of water. At the height of the Earth's orbit, you open it and pour out 1 drop. It accelerates and there's no resistance. It passes through the hottest layers of the atmosphere, but doesn't burn, passing the freezing temperature, but doesn't freeze up. It flies to the ground, developing the speed of light, and crashes again. But nothing happens. The drop got the properties of a light particle, a photon. It's only under such condition that it might develop the speed we need. No object with mass, be it a car, a house, a tree, an ant, a single air, a grain of sand, or a molecule, can reach the speed of light. Only light particles are capable of it since they don't have mass. An intangible drop falls into the center of the target, and again, nothing happens. The third option. Scientists found a way to accelerate a drop to the required speed. They also have to change the molecular composition of water, making it more resistant to high and low temperatures. To make the drop reach the speed of light without any damage, you need to place it in a perfect vacuum. No air resistance, no protective layers of the atmosphere. We leave only space and the water. For this purpose, scientists need to build a long pipe. In the center of the Sahara, around the same target, people create a scientific center. From here, the pipe should go up. Its height is approximately the distance to the International Space Station. That's 254 miles, which is about the height of 50 Everest mountains. You can't connect to the ISS itself as it's moving all the time. It revolves around the Earth, completing one revolution in 90 minutes. That's why astrophysicists and engineers should build a small station designed for one person, and this station should move parallel to a single point on the ground. The vacuum tube is made of solid stainless materials so that rain and high temperature couldn't destroy it. Inside, it's an alloy of titanium and graphene, the most durable metal on Earth. The pipe is built horizontally. Then, with the help of several helicopters and cables, it's placed in an upright position and attached to a small space station. The pipe is equipped with small pumps that pump the air out and block its flow inside. The water drop shouldn't touch the walls, so there's a special layer of gravity plates. They push the water away from the pipe's surface, using the power of magnetism and sound waves. You put on a jetpack and fly to the station with a bottle of upgraded durable water. Your hands are shaking with excitement. Your breathing sounds loud in the spacesuit. You open the bottle, tilt it slightly, and pour one drop into a special box. Inside this container, the drop gets charged with the energy needed to develop the speed of light. Now it's ready for the journey. You look at the box, close your eyes, and press the start button. The drop flies into the pipe at a great speed. From the powerful blast wave, the entire station is thrown to the side. The drop accelerates, and at this point, the pipe made of the strongest metals on Earth begins to melt like ice cream. There's so much energy in the water now that it would be enough to provide electricity to a small city. And now the drop reaches the speed of light, which is 186,000 miles per second. The pipe turns to dust. It doesn't matter whether the drop hits the ground or not, because there will be nothing. Literally all material objects, cars, houses, fields, oceans, computers, planes, ships, flowers, trees, should I go on, will disappear. Intangible things, such as gas, air, radio waves, electromagnetic radiation, billions of terabytes of digital information, all this will also be gone. Boy, are you in trouble. Any sound, shouting, music, the phone ringing, will be impossible to create and hear. The light will disappear, and then there will be complete darkness. But let's rewind time and see exactly what happened right now. It won't work, though, because there's no time either. Imagine time as a stormy river that flows rapidly in one direction. Then this river falls into an endless pit and disappears completely. All this happened because a drop of water crashed into our planet at the speed of light. As soon as a drop begins to approach the needed speed, it loses its properties of water. It's now the most powerful and heaviest object in the universe. The energy that comes from it destroys everything for hundreds of thousands of miles. Concrete, ground, rocks, etc., 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 and on and on and on. Everything disappears. In the first second, it all gets shattered into millions of tiny pieces. Then these pieces are torn apart into millions of even smaller particles. The molecules burn up. Imagine a paper map of the world. If you wet it and tear it, it will turn into wet paper scraps. If you burn it, then part of the map will turn to ashes, and the other part will simply fly into the air in the form of smoke. The map will remain, but it will never look the same. But if you destroy the map's molecules, it's safe to say that the map never existed. There's no trace of its existence. The same thing happens to our planet. The energy coming from a drop of water makes the Earth never exist in space. And now the drop exceeds the speed of light. A black hole starts evolving. It expands and absorbs all the space debris. Then the Moon. Soon it will be the turn of Mars and all the other planets in our solar system. The black hole expands and increases the force of gravity inside it. Together with our planet, it absorbs light. It's getting closer and closer to the Sun. Our star splits into strips of light as if it had passed through a huge cosmic shredder. The sun explodes and spits out an impossible amount of energy. It's believed that black holes appear after the explosion of stars. Right now, all the solar energy is being absorbed by our black hole. It's getting pitch black. The light from distant stars falls directly into the supermassive infinity. Meteorites flying within a radius of hundreds of thousands of miles around are also devoured into the unknown. There are many black holes in space, but only one of them was created by a small drop of water. The higher the speed of any object, the heavier it gets. Mass is the amount of energy that an object has. When water molecules reach the speed of light, their mass begins to grow, and there are no limits to this. It becomes infinite. An infinite mass forms a black hole. It absorbs everything, and nobody knows what's inside the black hole. All that remains is darkness and the unimaginable force of gravity. So, I'm guessing here that we probably should not be doing this experiment, should we? How about we make a baking soda volcano instead? Behold the distant future. Yep, humans have successfully colonized Mars and the Moon. Problems with overpopulation and hunger on Earth are solved. But soon, a new threat looms over our planets, and the Moon. Anyway, scientists have figured out that in 150 years, the Sun will explode and destroy our entire solar system. Bummer. There's enough time to build a fleet of huge spaceships and evacuate everyone, but it's not enough time to come up with some sort of sci-fi space jump. It's been a long time since people found a new, potentially livable planet, and the nearest one's a several million years ride away. There's no other choice. Humankind is evacuated into gargantuan spaceships, and the infinitely long voyage begins. A few decades pass. We leave the solar system and watch our sun explode. A huge flash and that's it. There's no more light. Just small, faraway stars and the infinite black depths of space. All ships are on a synced autopilot that won't go off course no matter what. Even if everyone on board were to disappear, the ship would still arrive at its destination. So, the upside, humans will survive for millions more years. The downside? Because of all of that time spent on space transports, will look different, totally different. Ships arriving to the new planet will be populated with shapeless, pulsating biomasses sitting inside metal exoskeletons. Here's how it happens. Bones in space get weaker, so do muscles. There's no gravity, so your body's not under any sort of pressure to keep it running properly. Astronauts on the International Space Station do a lot of exercise to stop their muscles from withering away. Back to the story. There are gyms and special machines that recreate gravity on every space transport. But to save energy, they're only plugged in a couple of hours per day. Unfortunately, no matter how hard people exercise, in space it just won't be enough. After the first 100 years, human bones have become so brittle that anything remotely physical can lead to injury. After another 100 years, people lose the ability to stand up on their two legs, but it's not only because of weak bones. After all those years in zero gravity, the human body's already changed a lot. A big problem is that people lose their sense of balance. If you try to stand up, you'll just fall. The ship's captains dismantled the gravity machines. They weren't working anyways. And all the sports equipment on board got taken apart ages ago and used as spare parts for the ships. The lack of gravity didn't just make people weaker, it also made them taller. The spine needs gravity to keep it stable, and now all those backbone discs have stretched themselves out. Humans are starting to look like blow-up toys. Everyone's given mechanical arms and legs. You just strap them on and get to work. Servicing the engine, cleaning out the bedrooms, throwing trash out into space, lifting anything. Not happening without those mechanical arms and legs. Time passes, and people become more helpless. Luckily, the mechanical bodysuits keep getting better and better. Since the sun collapsed in on itself, human eyes have been having a hard time. Inside the ships, the sun is replaced by special artificial light that also gives off vitamin D. Since there's way less light overall, people's pupils become whiter. Then after a few more centuries, their vision really starts going downhill. But this problem is solved by technology. Artificial lenses magnify light and keep humans from going completely blind. The ships get disinfected every single day. That stops bacteria and microbes from multiplying. But it also means that the human immune system doesn't have to fight off any diseases. Pretty soon, humans can't defend themselves against anything. Even a mild cold could be seriously harmful. It's fine for now. There are no germs or anything on board. But what's going to happen later on down the road? On the ship, millions of plants grow in special greenhouses with water and ultraviolet light. The plants produce oxygen and spread it through the entire ship. Of course, it's not enough oxygen to satisfy millions, but it helps people remember the planet they left behind. After centuries of living on spaceships, humans have adapted to the new conditions and almost stopped breathing. Lungs have disappeared almost completely, and humans are starting to develop other ways of getting oxygen. From water, from liquid oxygen tanks, we're becoming a totally new species. But it's not all bad. Genetic engineering is developing every year. Full-fledged life support suits are created. They help with movement, strength, speed, vision, hearing, even speech. People's voices get so weak they can only speak in whispers. Luckily, the suits have built-in microphones and speakers. There's no food anymore, just specially created liquids. After all that time in space, the human stomach can't digest anything anyway. Fancy a handful of peanuts or a small cracker? Forget it! In the beginning, the special space food had loads of flavor. But over time, people sort of forgot what things were supposed to taste like. Eventually, they stopped adding in flavorings, and because of this new tasteless food, tongue receptors stopped working. Soon, people lost all sense of taste. For some people, this life seems unbearable, but they have a choice. They can just slide on into a cryogenic capsule for millions of years. Then it's just a matter of a quick defrost when the ships finally arrive. But it's seriously risky to be frozen for such a long time. There's no guarantee that the ships won't crash into a huge meteorite, or worse. People start to take a different approach. They upload their consciousness to a central computer. It's safer and requires much less power. And when you wake up, you can just download your mind into a new, modified human suit. Some people decide to stay awake and live a, quote, normal life. Thousands of years pass, then millions. Humans look really different now. All their limbs are now artificial, and the exoskeletons they wear are controlled by mind power. With each passing millennium, arms, neck, legs, and spines, they become smaller and smaller. Brittle bones soon dissolve into nothingness. Eyes, nose, and mouths disappear. The brain isn't protected by a skull anymore, it's just surrounded by soft skin. Only consciousness remains. Nowadays, a human is a powerful high-tech robot ruled over by a small pulsating bag filled with a brain. It's been a few million years since humans left Earth. All the ship's inhabitants have already forgotten that their species was born on a planet with gravity. The history of life on Earth has become a myth, an ancient legend. Most people believe that these ships are their true homes, always have been. That's why, when humans finally reach their destination, no one's that eager to get off and have a walk around. Life on a new, unknown planet seems like a huge pain in the spacesuit. Gravity, air, bacteria, germs – it takes several thousand years of evolution for humanity to get used to these new conditions. Luckily, humans have a secret weapon – technology. At this point, all humans are downloaded from the central computer into new robot suits. People face a choice: get off the ship and make this planet their new home, or stay and live on the ships. Those that stay on the ships set off into the expanses of space to explore the galaxy and discover new worlds. Those who decide to stay on the new planet have to adapt to the new conditions. It's pretty different from Earth. There's a different air density, different weather patterns, and strange new chemical elements. It will take another million years before these robo-brain sacs take on a new shape. One day, these distant human descendants will want to research their origins. They'll invent a ship that can jump through space and time. The research will lead them to the distant past, to the small planet Earth, to now. This might sound crazy, but just imagine that tomorrow someone lands in your backyard and they're your descendants from the future. Those passengers who stayed on the ships will probably find new planets and maybe decide to stay on some of them. Their bodies will change and adapt too. So, in billions of years, the universe will be inhabited by different amazing creatures that all have something in common. They were all humans once. Whoa, something doesn't feel right. Everything seems shaky. It's definitely not an earthquake, and it's actually getting worse. The clouds seem to move quicker than usual, and the animals are going into a frenzy. The news anchor pops up on the TV in an alarmed tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second, and they don't know why." Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kind of makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there will be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function, and mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds. But around the equator, you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stop, since the radar systems have gone haywire and the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually we'll have a total communication blackout. Ships will cease to operate and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will now be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be in danger, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. the trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we'd probably feel like we're always on a jet plane going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day. So days would be around 7 hours long as well as nights. The whole world would be flooded, except for the highest points and the tallest mountains. If that happens, humans will most likely end up there clinging to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters like earthquakes, tsunamis, volcanoes, and even melting ice sheets have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour, and as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture, since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded, and the crust will be 80% gone. If it goes on any longer, there won't be any living things around, probably except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted. And with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the Moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the Moon's gravitational pull on our little blue planet. It'll most likely go on that way. So hey, what's your hurry? So we don't have all the details about how the universe, our solar system, and its planets came to be. But one thing's for sure, Earth didn't just pop out of thin air. Scientists have recently made an intriguing discovery that suggests our planet may have formed way faster than we previously thought. You see, up until now, experts believe it took over 100 million years for Earth to take shape. The common belief was that lucky collisions with water-rich asteroids brought water to our planet. A recent study, however, proposes a whole new perspective. According to these researchers, there's evidence that Earth formed through the rapid accumulation of tiny pebbles, each roughly the size of your fingernail. In this scenario, our awesome planet emerged in only a few million years. And here's the mind-blowing part. They suggest that water being here isn't just some happy accident, but a natural result of the formation process. Now, this discovery has implications that go beyond Earth itself. If our planet formed quickly and water was an integral part of the process, it means the chances of finding habitable planets in other solar systems are way higher than we ever imagined. If we stumble upon other planetary systems with planets orbiting sun-like stars at the right distance, there's a good chance we'll find water there too. That's some nice intergalactic real estate that we might just be able to relocate to, should we ever get in trouble here on Earth. The old-school view was that planets slowly took shape through countless collisions over millions of years. According to that theory, water on Earth would have been a random stroke of luck, maybe caused by comets packed with water crashing into the planet during its later stages of formation. The new study introduces an alternative theory too. Picture this: a young sun surrounded by a disk where the planets are popping up. This disk is filled with tiny dust particles. Now, here's where it gets exciting. Once a planet reaches a certain size, it acts like a cosmic vacuum cleaner, swiftly hoovering up all the dust in its path. In just a few million years, this tiny planet grows into the size of Earth. This not only shapes our incredible planet, but guarantees water's existence too. As the planet gobbles up the dust, it also snags icy particles floating around in the disk. So, if we use Earth as an example, it suggests that whenever a similar planet forms, it's bound to have water naturally. There's no way for us to travel back in time and see for ourselves, so there are more theories about how planets are born. Let's dive into a different scenario called the core accretion theory. Picture a big cloud of dust twirling around in space. That's where the action begins. Over time, this cloud starts pulling in an astounding 99.8% of all the matter, eventually creating our sun right at the center of our solar system. Soon enough, solar winds join the party, bringing in lighter atoms like hydrogen and helium that are closer to the sun. But those heavier elements? The sun can't pull them in because, well, they're too heavy. So what do? They gather together and stick to each other, forming their own little planets. That's how Earth, Mars, Venus, and the gang got together to create round spheres. The heavyweights, like zinc and iron, sank to the middle, forming the core, while the lighter elements meshed on top, creating the crust. But wait, we can't forget about Jupiter. Its gravitational force and the sun's were locked in an epic tug-of-war, perfectly balancing each other out. That's why we have that fascinating asteroid belt hanging out between Mars and Jupiter. Those poor asteroids never got the chance to become fully fledged planets on their own. This explains why the planets in our solar system are arranged the way they are. The inner ones, known as the terrestrial planets, like Mercury, Venus, Earth, and Mars, are closest to the Sun. They're made of denser stuff like iron, silicon, and aluminum. On the flip side, the gaseous giants like Jupiter, Saturn, Uranus, and Neptune are chilling on the outer edges of the solar system. These big celestial bodies are composed of lighter materials such as hydrogen, helium, and methane. Now, let's take a trip to the outermost layer of our solar system, where the Kuiper Belt and the Oort cloud reside. These distant areas are home to ice bodies, space debris, and comets. While there may be plenty of them, they're relatively small and don't contribute much to the total volume of our solar system. The quest to understand planet formation doesn't end here. There's another mind-boggling mystery that's causing a stir among scientists: the existence of a celestial body dubbed the planet that shouldn't exist. Let's rewind a bit. Astronomers have been on a roll with exoplanet discoveries, and we've already spotted over 4,000 of them. Most of these exoplanets resemble the gas giants in our own solar system, like Jupiter and Saturn. Do you know why? It's because those massive exoplanets close to their stars are the easiest to detect. But here's the twist. A new study suggests that there's a whole bunch of Jupiter-like exoplanets just waiting to be found, and they're probably hanging out nearby. This impossible planet goes by the impossible name JG3512b, and it's remarkably similar to Jupiter, only orbiting a tiny red dwarf star. This discovery shook things up because it defied the most popular theory of planet formation. According to the prevailing ideas, it should have been impossible for such a giant planet to form around such a small star. So, what's the deal with this impossible exoplanet? Well, it turns out that core accretion, the theory we discussed earlier, can't explain its existence. According to this theory, the mass of the debris disk surrounding a young star should be directly proportional to the star's mass. But here we have a star much smaller than our Sun hosting a planet that should be way too massive for it. Something doesn't add up. Either the original debris disk was insanely enormous compared to the star, or core accretion didn't play out as expected in this particular planetary system. We've established that when talking about the Earth's formation, there's still much we don't know. But hey, we've come a long way. Back in the 18th century, a philosopher named Immanuel Kant had his own intriguing theory about planets popping up in the universe. He based his ideas on Newton's law of gravity, but added his own little twist. Kant believed that the universe started with an original substance made up of super cold, solid particles just chilling out. Then, thanks to gravity, these particles began colliding and heating up. And you know what happens when things collide, right? They get hot. According to Kant, this cosmic twirling and heating up caused some serious forces to come into play. It's like when you spin around so fast that you feel like you're about to take off. These forces led to the formation of rings of matter, like cosmic hula hoops. And as these rings cooled down, they transformed into planets and satellites. Now, not everyone was convinced by Kant's wild idea of planet formation. Critics raised their eyebrows and started questioning the whole theory. They pointed out that Kant failed to address the origin of this primordial matter. Where did it come from in the first place? Moreover, he overlooked the source of energy that propelled these particles from a state of cold stillness to a frenzied cosmic dance-off. As creative as his theory was, it soon faced dismissal in the scientific community. In short, they said, this can't happen. Nevertheless, Kant's theory was still a step forward compared to older beliefs about Earth's origin. Take the ancient Egyptians, for example. They believed that primordial spirits, often depicted with frog heads in their native artwork, were responsible for our planet's existence. Why frogs, you ask? Well, they associated the first substance in the universe with water, and frogs just love humid environments. So, out of that initial water, a primordial hill emerged, followed by the elements of air and moisture. Ribbit.
The speed of light is the fastest thing in our universe. It travels across space, passing through Mercury and Venus to reach us, and it's slowing down. No need to panic though. The sun is getting weaker, but we won't see the effects of it for another billion years. In the vacuum of space, the speed of light is around 186,280 miles per second. Any slower than that, and humans would see the changes firsthand. There would be some awesome effects, like colors changing and the brightness of objects fading. We'd also notice some differences in everyday objects, their length and shape. Scientists created a simulation to see what would happen if the speed of light was slower. In a vacuum, the speed of light can't change. But if light passes through different materials and objects, it alters the way we perceive things. Light acts as a wave and a particle, meaning that it's a wavelength. The color and frequency are determined by the distance from crest to crest in the wave. It behaves similar to sound with the Doppler effect. Imagine you're standing in the middle of a busy highway and a honking car speeds through. Wow, that was loud. You can hear that whoosh-like sound of the horn because the moving object produces the sound while you're stationary. The frequency and pitch seem to change, but it's just the sound reaching your ear faster than it would if you and the car were both stationary. Light behaves similarly. The wavelengths change if the speed changes. Moving toward a light source and making the wavelength shorter will shift the color to a blue and violet hue. Moving away from the light source, and you'll get something more reddish. So if the speed of light slowed down to walking speed, we'd notice the colors changing when we approach an illuminated object. At the same time, the color would change around us and behind us. If you walk sideways, the colors you're walking toward would become bluer, and everything in the distance would become red. This information is useful to astronomers who are studying objects in space. If they're blue shifted, that means the object is moving towards us. And if it's red shifted, then it's going in the opposite direction. In fact, everything in the universe is red shifted, proving that the universe is expanding and getting further away from us. The slower it gets, the brighter it becomes. That's because the photons become more present for us to see. At this rate, we can see invisible light and increased intensity. You won't notice that effect much if you're standing still, but because of the Doppler effect, moving towards an object will have different colors and different light intensities. Another phenomenon we'd experience is time dilation. It's when you move at a similar speed as light and time decreases relative to someone who isn't. Space and time are relative. So if you're sitting at your desk wasting hours away, yeah, sounds familiar, doesn't it? All your movement will go through time and not through space. You're stationary, but you're still technically moving forward in time, slowly aging. The faster you move through space, the slower your movement through time will be. If you move at the same speed as light, then all your movement will be through space and not through time. To notice that, you'd need another person to watch you. You're not in a time machine. You're both on Earth, experiencing the same time flow. To you, experiencing this firsthand makes it feel like you're going faster, because you're getting a lot more movement in space in a given time. The closer you get to the speed of light, the smaller you become. Well, not really, but it depends on who's watching. If you're the one traveling at such a speed, an object nearby will seem small, just as someone who's watching you travel at the speed of light will think that you're smaller than you actually are. The simulation that the MIT scientists conducted showed that if the speed of light drops, everything will become stretched out like a pancake. If you see mountains in the distance and then run at the speed of light, they will appear further away. Objects will become distorted, and it will feel like you're getting to a certain place faster because time has slowed down for you. If you're standing completely still and someone standing on your left-hand side throws a cube-shaped object over to your right-hand side, then naturally, you'll see one side of it unless it flips around. But in this new reality, you'll get to see the front side wrapping around the visible side you're seeing. If you're moving at the same speed as light in an infinite space, everything will be stretched out as you reach infinite speeds. In a world where people can walk at the same speed as light, we'll perceive nothing as normal. We'll have to get used to the way we see objects. Every movement we make will result in drastic shifts of colors. Even turning your head to look at something will feel weird. Let's say you're in a supermarket buying groceries, and you walk from aisle to aisle. The milk at the end of the counter will look like it's really close to you. But when you approach it, you'll start to feel like it's getting further away from you. The milk will also look a bit red. As soon as you get closer to it, it will shift to blue. If someone is passing through with a shopping cart, you'll see it as a sort of 3D model of a shopping cart. The color will shift as it gets further away from you. It will appear far away, but it's right in front of you. In fact, we don't really know the actual speed of light. Physicists gave it roughly 186,280 miles per second, but that constant is just for them to calculate other scientific stuff so we can understand it better. The problem is that we can only measure light with the path and its reflected path. Einstein's theory of relativity states that the original path of light moving from the source to the mirror may not be the same speed as the reflected light from the mirror back to the source. Hypothetically, if it takes light 10 seconds to travel from the source to the mirror and then back to the source, then we can conclude that each trip takes 5 seconds. But Einstein's theory is that it could take 9 seconds for light to travel from the source to the mirror and only 1 second from the mirror back to the source. or vice versa, or maybe completely different numbers altogether. That's why it's so difficult to measure light. A breakthrough came out for scientists when they managed to slow down the speed of light to 0 without losing its brightness. They did this by using ultra-cold atom clouds made with photonic crystals. These crystals are materials punctured with billions of tiny holes where light can refract. But what if we lived in a world where light stopped halfway? You'd wake up one morning and feel like it's twilight. You'd open the curtains and see that many car lights are on but aren't so bright. You turn on the lights in your room but feel like the bulb is tapping out. You replace it with another one, but it doesn't do the trick. You turn on the lights everywhere in your house, but it's all just giving weak light. You're confused and try to check if there's a problem with the electricity in your house, but it seems to be working well. You check on your neighbors, and they also have the same problems. Even experts in the field can't understand what's going on. Hours pass, and it's all the same. All the light in the world seems to have frozen halfway. Your phone is low on brightness, even though you bumped it up to maximum. Everything is getting darker. You learn from the news that it's a global problem. Light is slowly diminishing, and soon there won't be any of it in the world. You decide to wait it out while everyone else is panicking.
Let's talk about cyberpunk, a really cool genre of science fiction that started in the early 1980s. Its pioneer writers were really interested in how technology was changing society, especially with all the digital evolution happening at that time. One of the writers, Bruce Sterling, wrote an introduction to a book called Mirror Shades, which was like a guide to cyberpunk. He said that this genre is all about looking at technology in a new way, not just for science fiction writers, but for regular people too. It's like imagining a world where high-tech stuff and the cool underground culture mix together. The heroes of cyberpunk stories are mostly rebellious people who stand up against big companies and the boring mainstream. They believe in being unique and doing their own thing, even when the world tries to contain their efforts. These heroes are really good at taking things from popular culture and using them to express their own ideas and interests. They also know how to use computers to find out secret information and spread messages that go against the system. These days, cyberpunk themes are seen in more than just literature. You can find their influence in things like movies, video games, and even fashion. It does make you wonder though, could the future truly turn out to be what cyberpunk writers predicted? Truth is, all the cyberpunk literature is packed with mind-blowing technology that might just become a reality one day. Like augmented reality, for instance. Now this might sound far-fetched, but we're actually getting closer to experience AR in our daily lives. I mean, some companies are already offering such devices. Right now, they're mostly used for gaming and entertainment, but soon enough, we might use them for virtual training, education, and even shopping for a new car or checking out a house. Next up, smart clothes. In cyberpunk video games, people are rocking these stylish garments that not only look cool, but also offer some serious protection. We're not quite there yet, but smart clothes are becoming a thing in our world too. You've probably heard of smartwatches and fitness trackers, right? Well, imagine clothing that can monitor your body's movements, suggest healthy habits, and adjust your body temperature. Some fashion brands are already exploring this exciting field. Now let's dive into virtual reality. In one particular cyberpunk story, there's a feature where you can customize your own virtual reality experience. It's like stepping into someone else's shoes and reliving their memories. Now, VR is already pretty amazing in our world. We use it for medical purposes, gaming, and tourism. And here's something even cooler. Imagine being able to feel things in virtual reality. Yeah, it's called haptic technology, and it's being developed to make VR even more immersive. You could use it to control machines, learn in a virtual classroom, or even attend a concert with friends who are miles away. Last but not least, we have artificial intelligence. In a cyberpunk scenario, AI is everywhere. from brain analysis to taxis with intelligent controllers. Now, we might not have all that advanced AI just yet, but we're definitely making progress. You're probably familiar with all those virtual assistants featured on smartphones. Well, imagine them getting even smarter. AI is expected to be integrated into so many aspects of our lives, like fridges that can automatically order groceries when we're running low, self-driving cars, and delivery drones. And hey, AI is already helping companies suggest personalized content based on certain preferences. In the future, it might even help us find the perfect recipe for dinner or recommend the ideal cosmetic product just for us. Then, there's the potential for a brain-computer interface, or BCI for short. In a cyberpunk world, it's like a special connection between our brains and the internet that would allow people to virtually explore using just their minds. In the real world, scientists are already working on developing BCI systems. They can read the signals from our brains and turn them into commands. So instead of using a keyboard or a mouse, we might be able to control objects just by thinking. Right now, these BCI devices are being used in research settings, but someday they could be used to support people. They could help with regaining useful functions and improve rehabilitation. It doesn't stop there, though. BCI could also help professionals like pilots and surgeons. It could make their natural skills even better and help them do their jobs with even more precision. But, there are also some things we need to be careful about when it comes to this cyberpunk technology. In the cyberpunk world, there are serious problems to consider. One of the concerns, for instance, is that if we rely too much on technology, it might start making decisions for us. We might become less skilled at day-to-day tasks because we let the machines do everything for us. That's why we should focus on using our own resources to make our own choices. Another thing we need to watch out for is protecting our information. All sorts of security breaches are already happening all over the world. We need to make sure we have strong measures in place to keep our information safe. Science and technology are moving at an incredible pace these days. It's hard to pinpoint what the future might look like, but you surely have some sort of scenario in mind. Maybe you envision a world where robots and AIs, controlled by a handful of powerful corporations or individuals, dominate the scene with unjust power structures. Or perhaps you picture sprawling cities filled with skyscrapers and flying cars, shrouded in perpetual darkness. And maybe the future seems bleak, where only a privileged few have access to nature, while the rest struggle to make ends meet on a harsh planet. In the cyberpunk world, our planet is either on the brink of a disaster or has already fallen into complete ruin. The stories consistently revolve around dominance and control, whether it's between the rich and the poor, corporations and the market, or humans and the AI robots they create. Cyberpunk is all about systematic and oppressive inequality. It's also about a future where most humans live in a highly mechanized society that disconnects them from the rest of the natural world. In this potential future, all the amazing technologies we've created don't really improve the lives of most people. In fact, they make things worse. It's not all bad, though. Sci-fi can be more than just entertainment. It has a way of inspiring and shaping our real world. Throughout history, designers have drawn inspiration from sci-fi for inventions for things like flip phones, self-driving cars, and even the concept of the metaverse. There are also many interesting alternatives for the future. Ever heard of solarpunk? It's also a genre of speculative fiction, but one that envisions technology and the environment evolving together. The solar part is all about the power of solar energy, while the punk part puts it in the same awesome group as other sci-fi genres like cyberpunk. So what does solarpunk actually look like? Well, imagine visually stunning utopias that are all about the environment and being positive. In solarpunk worlds, they've totally sorted out how to correctly use the planet's resources, or are actively working together to fix it. It's all about coming together and being friends in the fight against a bleak future. When you enter a solarpunk universe, you'll be greeted by groovy green tech, cities that are super walkable, and tons of lush greenery. It's all about living in harmony with nature, while still rocking the latest technology. It's like the complete opposite of Cyberpunk, which is all about grimy cities, greedy corporations, and fear of outsiders. Solarpunk is all about putting people first and recognizing the amazing connection between human intelligence and the Earth. One of the major influences on solarpunk is Art Nouveau. This art movement is all about embracing organic and earthly shapes, and it fits perfectly with solarpunk's vibe. Another cool reference for solarpunk is the arts and crafts movement from the late 19th century. It was all about rebelling against unnecessary waste.
Our good old solar system is actually a pretty bizarre place, what with all its out-of-this-world phenomena that we humans haven't managed to explain yet. There are rumors that a gigantic, undiscovered planet is hiding behind Neptune, volcanoes on Pluto spew ice, and a colossal canyon on Mars can accommodate the whole US territory and most of Cleveland. Well, let's figure out if it's true by talking about the most mystifying solar system facts. The solar system is 4.6 billion years old. So old it's a senior solar system. Scientists came to this conclusion after they studied the oldest material they managed to get a hold of. And by that, I mean meteorites, of course. You won't be able to wear a hat on Venus, ever, and just try to stand on your feet. The planet is insanely windy. Its upper winds blow 50 times faster than the planet rotates. What's more, these fierce winds never stop and can get even stronger with time. Want to get away? You'll have to travel 11 billion miles away from Earth before ever leaving the solar system. Take your Google Maps with you. You probably heard of methane gas, a byproduct of natural processes such as volcanic activity and cows. Anyway, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be cows on Mars? As you may remember, Pluto used to be a planet but was stripped of this title in 2006. Later, it was reclassified as a dwarf planet. Gee, make up your mind. But the most unexpected fact about this celestial body is that its diameter is smaller than that of the US. See for yourself. The greatest distance across the country, from Maine to Northern California, is about 2,800 miles. As for Pluto, it's only 1,473 miles across. The planet Uranus, or Uranus, you can't win either way, rotates on its side, and astronomers have no idea why the planet has chosen such an unusual position. The culprits could be ancient mega-powerful collisions, but so far it's just a theory. By the way, this is the only planet laying on its side. Our Sun is insanely massive. Want some proof? Well, 99.86% of all the mass in the solar system is in the mass of the Sun, in particular the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Earth might not be the only tectonically active planet in the solar system. Astronomers have spotted some landforms looking like cliffs on Mercury. If it's so, the tectonic activity could explain the rapid shrinking of the planet. In most sci-fi movies about space, the main character gets into an asteroid belt and must dodge countless rocks that threaten to damage their spacecraft. Well, sorry to disappoint, but that's nothing like the real thing. The only asteroid belt astronomers know about is located between Mars and Jupiter. There are thousands of asteroids in this region, but they're so widely spaced that the chance of collision is next to nothing. You just ruined it. Sorry. Behind the orbit of Neptune lies the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists can't explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet from our sight. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not. Volcanoes on Earth are as different from those on Pluto as fire and ice, and I mean it. While we have volcanoes spilling lava on our planet, the volcanoes on Pluto spit ice. When frozen water expands, and this enormous pressure builds up until one day, bang, the ice erupts. In the process, a new cryovolcano gets formed. One of Saturn's moons, Lepidus, has a unique color. It's two-toned. One of its hemispheres is light and the other is eerily dark. Scientists haven't figured out this mystery yet. There's another weird thing about Pluto, or rather, about its atmosphere. First, it rises way higher above the surface of the dwarf planet than, for example, the Earth's atmosphere. What's more, the atmosphere on Pluto has more than 20 layers, and all of them are super cold and very condensed. We live inside the Sun. No, I don't mean that we're inhabitants of the red-hot ball of light approximately 93 million miles away. The thing is that the Sun's atmosphere stretches far beyond its visible surface, and our planet is right within its reach. In fact, it's the gusts of solar wind that create the breathtaking phenomenon known as the Northern and Southern Lights. The ocean on Jupiter is larger than any other on the rest of the solar system's planets. But wait! It's not the type of ocean you're thinking about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is a staggering 25,000 miles, which is almost the same as the circumference of the Earth. The Sun's atmosphere is hotter than the surface of the star. While on the surface, the temperature reaches 10,000 degrees Fahrenheit, the upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the Sun may have something to do with this unique phenomenon. People came to know about Saturn's beautiful rings in the 1600s, but only recently it became apparent that Saturn isn't the only ringed planet. All the gas giant planets, Uranus, Neptune, and Jupiter, have rings of their own, but they're thin and almost impossible to see. As for Mars, Venus, and Earth, they're made of rocky materials and have no rings whatsoever. Our solar system isn't the only one in the Milky Way galaxy. Far from it. The galaxy we live in houses about 100 billion solar systems. And if that's just our galaxy alone, can you imagine how many there are in the whole universe? At any given moment here on Earth, you can stumble across a rock that's arrived from Mars. After scientists analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places on our planet, they came to the shocking conclusion that they have a Martian origin. Since Mercury is the closest planet to the Sun, many people simply assume that it's also the hottest, and that's where they get it wrong, because, in fact, Venus, which is about 30 million miles further from the Sun than Mercury, is way hotter. The thing is that Venus has an incredibly thick atmosphere, which is 100 times denser than the one we have on Earth. On top of that, this atmosphere consists almost entirely of carbon dioxide, also known as a greenhouse gas. These factors make the temperatures on the planet rise to a staggering 875 degrees Fahrenheit, which is hot enough to melt lead. As for Mercury, its maximum temperatures reach only 800 degrees. Jupiter's moon, Io, exists in never-ending chaos due to hundreds of smoking volcanoes on its surface. If you ever visit this place, send me a postcard. Now, you'll see the smoke from these volcanoes billowing up high into Io's atmosphere. The most enormous volcano in the whole solar system, at least that we know of, is on Mars. The size of this monster is almost as great as the state of Arizona, and its height is as big as that of Mount Everest. How did it grow this huge? The answer is simple. There's much less gravity on Mars in comparison with our planet. Even if you're a tiny celestial body, you can still have a moon of your own. Hey, it's not that hard. In 1993, the Galileo probe was traveling past a miniature asteroid that was no bigger than 20 miles across, and discovered the little thing had a 1-mile-wide moon. Since then, astronomers have found tons of moons orbiting minor planets in our solar system. The valley called Valles Marineris on Mars is more than 10 times larger than Earth's Grand Canyon. And it's another thing that puzzles astronomers. After all, Mars isn't a planet with active plate tectonics. On the surface of Jupiter, there's a weird region that's called the Great Red Spot. Recently, astronomers have concluded that this spot is actually a storm that's been raging on the planet for centuries. But some 20 years ago, scientists noticed that the red region started to shrink. Nowadays, it's just half the size it used to be. And still, the spot is 1.5 times bigger than Earth. How about you? Do you know any other unusual facts about our solar system that I've missed? Then let me know down in the comments. If you learned something new today, then give this video a like and share it with a friend. But hey, don't go space traveling just yet. We have over 2,000 cool videos for you to check out. All you have to do is pick the left or right video, click on it, and enjoy. Stay on the bright side of life. Okay, so you've seen the movies and read the books on time travel. Most of them tell stories about entering some futuristic boxes, and in the blink of an eye, you're in some different epoch. For now, this is just sci-fi. But there are ways to make time travel possible, at least theoretically. We just don't have the technology figured out yet. For starters, time travel to the future could be achieved by traveling at high speeds, but not just getting a ticket on the superhighway kind of speed. This is based on Einstein's theory of special relativity. It explains that time slows down for objects that move at really high speeds. And the good news is scientists have already tested this theory, and it looks promising. They did it with the help of 2 identical clocks. One was placed on a jet, and one stayed on the ground. They found that the clock on the jet ticked slower than the one on the ground because of how fast the jet was moving. The faster an object is moving, the more time will slow down for it. Currently, the fastest speeds achieved by human technology are seen in a special type of particles called neutrinos. Some of these can move at almost the speed of light. At these speeds, 1 second for the protons is equal to 11 months for us. Now, we might be able to time travel to the future with the use of gravity, too. This idea is based on Einstein's findings, namely his theory of general relativity. Now, this theory explains that the stronger gravity is, the more slowly time moves. This means that as you get closer to the center of the Earth, the strength of gravity increases. And if you think about it like that, time actually passes more slowly for your feet than for your head. Now, is that why I'm always late for stuff? Good excuse. This effect has been measured too, with the help of the same strategy with 2 identical clocks. Scientists placed them on shelves at different heights and measured the rate of ticking. The clock on the lower shelf ticked more slowly because it experienced a slightly stronger gravity. But this option comes with a catch. To be able to travel to the far future, you'll need to find a place with extremely strong gravity, like a black hole. That's a point in space where the gravity has so much force that even light cannot escape it. There, gravity becomes so intense that matter gets squeezed into a tiny space. The closer you get to the black hole, the more slowly time moves. However, traveling via a black hole is very dangerous, mostly because it's a one-way ticket. Once you cross its edges, there's no coming back. Now, here's a fun fact. The GPS systems we use on our phones and in our cars already have to account for time dilation effects in order to work properly. That's because of the speed of the satellites they use and the gravity they feel here on Earth. Without these corrections, your phone's GPS wouldn't be able to pinpoint your location on Earth very precisely. Meanwhile, the third option has less to do with the universe's unknown forces and more to do with our own bodies. Scientists are trying to find ways to time travel to the future by slowing down the body's own processes. It's not time travel per se. You wouldn't technically be going anywhere. But if your body stays put for a long period of time, you could eventually wake up in the future. Some animals, like bears and squirrels, can slow down their metabolism during hibernation, which means they don't need as much food and oxygen to survive. Specialists are trying to figure out if humans can do the same thing. They're working on ways to make people go into a short-term hibernation for a few hours to begin with. This could be helpful for medical emergencies too, in order to help a person before they can safely get to the hospital. In 2005, scientists were able to slow down the metabolism of mice by exposing them to a small amount of special gas. However, when they tried to do the same thing with larger animals, it did not work as effectively. Our fourth option of traveling through time is really unique. It involves a special type of shortcuts that may exist in our universe called wormholes. Now, before we move on, let's try to understand what they are. You'll need to picture two balls and a trampoline. If there's no pressure applied on the trampoline, it stays flat. Now imagine the two balls placed on the trampoline symmetrically. If you look at them from this perspective, there's no possibility of them ever touching. But if you put enough pressure on the trampoline between the two balls, this flexible fabric can stretch so much that the two objects might potentially touch each other. The same thing happens with stars in different star systems. They're big enough to curve space around them. That's why most planets tend to orbit around a star. The tunnel between those 2 points would be a wormhole. These wormholes could be used to travel long distances, like 1 billion light years, or even visit different times. Now, many scientists, like Stephen Hawking, think that wormholes might appear and disappear, but be very small, smaller than atoms. The problem is that we don't know how to catch one and make it bigger so that people can use it. This would take a lot of energy, and we don't know if it's even possible. Some astronomers say that even if we could find a wormhole and enter it, it would rapidly collapse on itself. Even the tiniest bit of extra mass, like that of our bodies for example, can result in the wormhole slamming shut, like a rubber band that's been stretched too much. Now, the fifth solution for time traveling was proposed by an American physicist named Ron Mallett. It involves one resource that we know for sure is abundant in the universe – light. The scientist proposed a theory about time travel that would use a rotating cylinder of light. He believes that if something was dropped inside this swirling cylinder, it could be moved in both space and time, similar to how a bubble moves when you swirl it with a spoon in your coffee. According to Mallett, the right shape of the cylinder could allow for traveling to both the past and the future. The physicist has been trying to raise money for an experiment to test his theory. This experiment involves dropping tiny particles, called neutrons, through a circular arrangement of spinning lasers. However, other scientists say Mallett's theory is impossible and there's no need to test it further. Well, even if we eventually figured out a way to travel back in the past or to the future, would it be safe? Scientists have been talking about a problem called the paradox of time travel for a long time. The main question is what would happen if you went back in time and did something that changed the future. However, a new study from researchers from the University of Queensland says that this problem might not be real after all. The scientists have done some calculations and found out that even if you had changed something in the past, the timeline would still end up the same way. Another variation of this problem is called the grandfather paradox. Imagine going back in time and preventing your own grandfather from having offspring. Come to think of it, it automatically means you shouldn't exist in the first place. If your grandparents didn't have your parents, how can you exist at all? Well, these days scientists are certain that even if you did experience something like that, you'd still exist in the present. That's because the timeline that already exists has a way of adjusting itself, regardless of where people are in time and what they do. Or somehow get 1.21 gigawatts in a DeLorean and make like Marty McFly.
For more than 170 million years, they dominated our planet. From small creatures that were only a few feet long to some of the biggest animals to have ever roamed the land. Let's admit it, the age of dinosaurs gave us some pretty scary predators, like T-Rex, Spinosaurus, the Velociraptor, Gigantosaurus, and so many others that made the rest of the animals shiver in fear. But everyone talks about dinosaurs all the time, so it seems like no other scary beasts ruled the animal kingdom besides them. But check out these reptiles. They dominated the prehistoric world for more than 120 million years, way before dinosaurs. But even before them, nature had to create the first true reptile. There was a swampy, wet era when many new groups of plants grew into great forests in tropical deltas and swamps. Trees were not like those we see today. They were mostly horsetails, club mosses, and the first seed-bearing plants called gymnosperms. It was during this time that the first peat bogs formed too. The most common creatures on land were prehistoric amphibians, which evolved from fish that were basically sick of being in the water all the time. So they decided to take a walk to see what was happening on dry land. Those early amphibians had a problem though. They depended on water to stay well hydrated and lay their eggs, so they couldn't go too far from lakes, rivers, and oceans. At least not until a special creature called Hylonomus evolved. With its 4 legs and scaly skin, we're looking at our best candidate for the first true reptile. These features help the animal move away from the water and explore dry land. As plants were intensely growing back then, they produced more and more oxygen, which probably helped these complex animals, such as our buddy Hylonomus here, develop. Let's rewind the story a little bit. 300 million years ago, Earth was hotter and drier, which was not that good for amphibians, but was great news for small reptiles like Hylonomus. These reptiles were able to regulate their body temperature and lay eggs on land, so they didn't need to stay close to water. That's when they started evolving into different groups. One was called pelycosaurs, and they lived in different ways. Some ate plants, while others preferred meat. You might recognize the most famous one from their group, with a big sail on its back. People often mistake this creature for a dinosaur. Over time, some pelycosaurs evolved into the so-called mammal-like reptiles we called therapsids. Therapsids had stronger jaws and sharper teeth, and some could stand upright on their legs, unlike their ancestors that moved more like lizards. Take Gorgonopsians, one of the top predators of their time that even dinosaurs wouldn't have liked to face. In a way, they were similar to mammals because they were probably endothermic, which means their body had a constant internal temperature. They had long legs, good for running and hunting. They mostly lived in southern Africa, but their fossils were spread across Europe and China too. Oh, the joys of times when continents were joined together. Top predators had no limits back then. Gorgonopsians went after different animals, especially those armored ones related to turtles. That's the type of chase I wish I had the chance to see. Some Gorgonopsians had really big skulls, almost 1.6 feet long. Scientists think some of them may have hunted in groups, but we're not sure about that. One specific Gorgonopsian was about 3.2 feet long and had a skull that looked like a wolf's face. It had long, sharp teeth in both the lower and upper jaw, similar to the saber-toothed cats. You may have heard about these from the Ice Age. Such teeth were good protection in such messy, insecure times. And we need to mention the Permian extinction. About 250 million years ago, 90% of all species, including animals in the seas and on land, as well as most of the trees, disappeared from the face of the Earth. Why did this happen? Scientists are still not sure. One theory says it may have been a massive asteroid impact, while another theory claims the spread of toxic levels of carbon dioxide in the ocean erased marine life. There's also some evidence of massive volcanic eruptions around the same time as the extinction. These eruptions could have released gases into the atmosphere, causing acid rain and making our home planet cooler. And all these things might have affected life in the ocean and reduced diversity in animal and plant kingdoms in general. Whatever the reason for the worst mass extinction in the history of our planet was, the rhapsids managed to go through all these troubles and survive. Not only that, they spread out and evolved into many different groups. Some of them even got cool features that made them more similar to mammals. Fossils show some reptiles had fur and maybe even warm-blooded metabolisms. They may have had wet black noses, like dogs, but it would be tricky to take this one for a walk. One of them might have given birth to live young, which is a characteristic of mammals rather than reptiles. Unfortunately, the rhapsids eventually went extinct and ended up being replaced by archosaurs, which were finally the ancestors of dinosaurs. But not all of them disappeared. Some survived alongside dinosaurs for millions of years. That probably wasn't an easy task. They continued to evolve and eventually became the first prehistoric mammals. But moving back to the pre-dinosaur era. Wait, what's that buzzing sound? Oh wow, the biggest insect ever! Yup, it's Meganora, a giant dragonfly that lived about 300 million years ago. Its wingspan could be more than 28 inches. They were predators and would mostly go after other insects, but I'm not sure I'd feel safe if they were flying around these days. Imagine getting back from a camping trip and instead of scary stories about terrifying beasts wandering in the woods, you only have one where an insect pushed you down and stole your stuff. And it's really weird these insects could grow so big during the period when they lived. One idea says it's due to higher oxygen levels in the air at that time. A lot of carbon ended up trapped in plants, so the oxygen levels were higher. Insects breathe in a different way than most animals. They have these special tubes called trachea that deliver oxygen directly to their body tissues. But this system is not very efficient for bigger insects. Oxygen moves slowly through the trachea, so the tissues in the middle of big insects wouldn't get enough oxygen to survive in today's world, where there is less oxygen. And for that, I'm very, very happy. And what about Arthropleura, a giant millipede that lived more than 300 million years ago? It was one of the biggest invertebrates ever discovered that could grow up to 8.5 feet, similar to a small car. Now that's a ride I wouldn't like to take. And once again, lots of oxygen probably gave a chance to these creatures to grow up to be the biggest of their kind. Arthropleura weighed around 110 pounds, which would be similar to a big dog. And it used to roam the beaches of ancient England. Well, okay, I'm fine. I'll find a pool somewhere. And their fossils showed us where they lived. Many used to think they preferred coal swamps, but newer research tells us they mostly lived in open woodlands. They could get a lot of food there, like seeds, nuts, and of course, some other small innocent animals. These creatures existed for about 45 million years and went extinct more than 250 million years ago. No one knows for sure why they disappeared, but some scientists believe they may have been competing with reptiles that eventually replaced them. And this slowly led to the rise of our beloved dinosaurs.
A space settlement floating out there in the cosmos. It's not sci-fi. But, as always, there is a catch. Look at this tiny deserted asteroid. It may look lonely and barren, but if you peek inside, you'll see life blooming inside of it. These days, many people now live right inside these asteroids. It's not sci-fi. According to researchers, we might be able to create futuristic cities the size of Manhattan on gigantic space rocks. Of course, there's a catch. The asteroid we choose as our base has got to be at least 1,000 feet wide. Though it's weird why life is inside this asteroid and not on its surface. You see, we can't really live right on asteroids. That's because we're not the little prince who indeed lived on an asteroid, according to the plot, but because there's too little gravity and too much radiation for us to handle if we chill outside. There are possible theoretical ways to stay on the surface, but it's going to be extravagant. So the only option is living inside asteroids. Nothing screams wildly theoretical like building an asteroid city. Living in space without any gravity isn't as romantic as it sounds. Researchers show that when people spend too much time in zero gravity, things start getting weird. Their eyeballs pop out, retinas detach, muscles shrink, and bones become as fragile as a potato chip. But imagine this, a space settlement floating out there in the cosmos. If you've watched enough sci-fi, you'd picture a massive structure spinning round and round. It spins to create gravity for all the lucky folks living inside. There's an actual prototype of this wizardry, the O'Neill cylinder. This device is named after physicist Gerard O'Neill, who came up with the idea for NASA in the 70s. Now, there isn't a ton of data on this, but humans need roughly 1/3 of Earth's gravity to function properly. An O'Neill cylinder may not be able to generate massive amounts of gravity, but the genius behind it, Mr. O'Neill himself, designed them to spin around their long axis. This device creates a gravity-like force called centrifugal force. So, if we ever get to use that, we'll be living happily on the inner surface of the cylinder, feeling pulled downward away from the center. But, as always, there is a catch. When the team crunched the numbers, they realized that the asteroids would break apart way before they could reach the speeds necessary to keep us grounded. And to make matters worse, most of these asteroids were more like loosely assembled piles of rock than a solid chunk. The small ones, like less than 6 miles across, are a mix of sand, pebbles, rocks, and boulders. They're all held together by the weak force of their own gravity. If you were to spin one of these asteroid buddies, all those parts would go flying off into space. Not cool. However, scientists didn't give up and they elaborated on the idea. They needed to find a way to keep the asteroids together. They played around with different ideas and they produced something crazy. Now, if you were to carry all your personal belongings every day right in your hands, at some point, the situation would be out of your control. You'd have to collect all your stuff from the floor. But you're smart and you carry a bag, right? Well, it seems that if we want to control an asteroid, all we need is a ginormous bag. But not just any bag, a massive, flexible, and super lightweight mesh bag made from teeny-tiny carbon nanofibers. These fibers are like tubes that are only a few atoms wide, but boy are they strong. So once we've got this cylinder-shaped bag all set up, we can start slowly spinning the asteroid using rocket motors deep within the rubble. And as it spins faster and faster, it'll start flinging all those pebbles, rocks, and boulders. And guess what? The carbon nanowire webbing is going to go flying out with them. This bag will be expanding and expanding until it reaches its absolute limit. And then the rubble inside slams into the now super tight webbing. It's like a crazy explosion of debris compacting together to create this massive hollow cylinder made entirely of concrete. Once all the dust settles, you can build entire towns, cities, parks, and even farmland on the inside of the cylinder. This is like something straight out of O'Neill's designs. You can even enclose the whole inner surface with a transparent roof. Outside of this incredible living area, you've got these thick concrete walls that are like superhero shields protecting against radiation. So not only do you have this space to live in, but you're also super safe from any harmful stuff outside. We still don't have this magic bag, as those magic carbon nanowires aren't mass-produced yet. But scientists claim that, according to the laws of physics, a tiny asteroid, like a few football fields put together, can be transformed into 22 square miles of living space. As of now, about 1.5 million people are living in Manhattan, and there are like tens of thousands of asteroids just hanging around in our solar system. You do the math. Seems like everyone will have a sweet spot to crash in space. Building a city in space is no easy feat. The main challenge still is to create a self-sustaining closed system that can keep going for the long haul. You see, cities on Earth rely on a much larger area to survive than just their own boundaries. But in space, the farther away from external resources a space city is, the more it needs to close its loops for oxygen, water, and food. Take the ISS, for example. It's about 40% efficient in recycling oxygen, but even then, its CO2 levels are always sky high. NASA is on the case, though, trying to figure out how to magically turn that CO2 back into oxygen. Once we've tackled the basics, like protecting ourselves from radiation, dealing with pesky gravity, and finding some air to breathe, it's time to get creative in space. Enter 3D printing and rocket engines, the dynamic duo that will pave the way for space settlements. With 3D printing, we can kiss goodbye to relying on Earth for spare parts. We'll simply whip them up locally, cutting out the middleman. We can even use 3D printers to whip up a delicious pizza in a couple of minutes. Of course, we'll need some fresh ingredients, but your dinner might just be a push button away in space. To truly thrive out there, we'll need to tap into the riches of asteroids. These celestial treasures are bursting with raw materials, perfect for creating solar arrays, building materials for our colonies, and so much more. And let's not forget about comets. These icy wonders are like cosmic water fountains, providing us with precious H2O for drinking, bathing, and even shielding ourselves from radiation. Plus, we can use that water to produce hydrogen and oxygen for rocket fuel and fuel cells. So, let's say we pull this off. Can you imagine people living or born in space might end up being different from you and me? Like if humans can have babies up there, these space colonies might develop some cool cultures. They might even come up with their own languages, and get this, they could even evolve new physical traits. It's wild to think that just after 300 years, a colony of 2,000 people could look and act so differently from us. They might have different hair textures, skin types, and even be taller or more slender to deal with that low-gravity situation. We might even develop new organs to protect us from cosmic rays. Or we'll have gill-like structures to breathe carbon dioxide. Hey, I know, it sounds crazy, but these scientists are working on developing these carbon nanotubes as we speak. So maybe one day we'll be living it up on our very own asteroid crib. It might seem like asteroid cities are just too far-fetched, but let's take a trip back in time for a moment. In 1900, no one had ever flown in an airplane, but today, thousands of people are zooming through the sky, comfortably seated in chairs, traveling at hundreds of miles an hour high above the ground, unaware that their luggage is on another plane going to a different destination. Ah well.
Hey there, Brightsiders! My name is Tom, and today I welcome you to have a peek into the future. Let's imagine it's your birthday and the entire family is here to celebrate. It's a nice group of 562 people. Perfect. It takes a village to put down 1,000 candles. You cook that 40-layer cake and build that house yourself. With the new average life expectancy, you have enough time to master any hobby in the world. This is no sci-fi plot. There is someone in the world today who will live to be 1,000 years old. It could be your neighbor's granddaughter, your best friend, or even you. Thanks to better nutrition, easily available clean water, and a huge progress in medical science, people are already living much longer today than they used to 150 years ago. Now scientists are trying to figure out a way to slow down, halt, or even reverse the aging process. One of the leading experts on aging, Aubrey de Grey, is positive humans can medically defeat it. Aubrey had a successful career in IT, then he fell in love with biology and decided to solve the aging problem. So he went back to Cambridge to earn a PhD in biology and later invested most of his inheritance in his project. Almost all living beings age, but they do that at different speeds and in different ways. Quahog clams can live for over 500 years. A female mayfly has a full life cycle of less than 5 minutes. Scientists have already managed to extend lifespans of yeast, worms, fruit flies, and small mammals thanks to genetic manipulation and stem cell therapy. All living beings are made of the same chemical building blocks, so similar strategies could work for humans. Dr. de Grey explains aging as a result of metabolism going wrong. He discovered only 7 types of possible causes of it. If scientists can learn to settle that molecular and cellular damage before it gets too dangerous, they could prevent people from aging. Dr. de Grey believes that we'll be able to solve these problems in mice and stop their aging in 10 years with stem cell therapy. When it's done, scientists would need another 15 years to find similar solutions for humans. Stem cells provide new cells for the body as it grows and can replace lost or damaged cells and tissues that your body wouldn't manage to cope with naturally. It's possible because they can divide over and over and over again. Plus, stem cells have all the genetic information and can turn into any other type of cell. Adult stem cells are already used to treat some conditions. There are technologies that, in theory, can take and relocate strands of DNA and add or remove DNA. It would be as complicated as taking 850 volumes of Shakespeare and editing just one certain letter. Changing DNA in the future can help preventing aging and extend life. With every round of therapy, the patient would get healthier with younger organs, nerves, and bones. Dr. DeGray explains, humans of today will unlikely invent a therapy to make you live to 1,000. But scientists can give humans an extra 30 years. It would mean some extra time for new research. New therapies could be invented then and give humans another 50 years. This way, step by step, humans would stay ahead of aging, and someone living today can eventually celebrate their 1,000th birthday. The oldest officially confirmed age record for humans so far is 122 years. I sure hope my retirement plan would last that long. Don't want to be working at a fast food joint when I'm 370 years old. Well, anyway. Evolution has never stopped. Some scientists say it's been going up to 100 times faster over the past 10,000 years than ever before. The average body temperature has been going down with every decade for the past 200 years. In 1868, 98.6 degrees Fahrenheit was considered normal. Now, it's around 97.9 degrees. This happened thanks to progress in curing some infectious diseases that speeded up metabolism and made internal temperatures higher. It's also because people spend most of the time indoors with a nice cool climate now and don't need to make an effort to keep a natural body temperature. Over the last 150 years, the average height of an adult has grown by 4 inches. Humans also grew 14% heavier on average, some heavier than others. This became possible thanks to better nutrition, food, distribution, healthcare, and hygiene. Scientists are sure this trend will continue in the future. Taller and heavier people will need more calories, so this could be a problem. The genes are constantly changing too. Several thousand years ago, adults couldn't drink milk because a specific enzyme was turned off. When raising cattle became more popular, more and more people got the genes that control lactose tolerance. In India, a large group of vegetarians developed a mutation in one gene. It let them process certain fatty acids from non-meat sources and convert them into important nutrients for a healthy brain. People on a meat-based diet rarely have the gene. The bones are becoming weaker and less dense. This process started around 12,000 years ago along with farming. Diets and physical activity changed back then, and it made the human skeleton more fragile. This trend will likely go on as people are moving less and less these days. Some people who live in houseboats in Southeast Africa have developed larger spleens than their neighbors. This adaptation helps them stay underwater for a long time. They spend most of their lives fishing and collecting shellfish. In 100 years from now, people will get regular body upgrades, even if they don't need them for medical reasons. Some companies already produce mechanical exoskeletons to make factory workers more productive. There are also exoskeletons for skiers to make them faster. With the technology of the future, there will be more robotic limbs. They will mimic or replace certain organs and will let people live out their dreams. You'll be able to climb Mount Everest at 80 with bionic organs controlled from your smartphone. Okay. You'll get new senses as well. Technology will let you feel the seismic activity through sensors on your feet, hear color waves through an antenna in the skull, predict weather through gadgets in your ears, and have other senses you can only dream of now. This could make humans closer to nature than ever. Or not. Humans will outsource more of their cognitive abilities to gadgets. Most people already can't read maps because gadgets just tell them where to go. There will be brain-machine interfaces, and you'll be able to transfer your thoughts online and analyze them. You already do something similar to your steps and your calories with apps that track them. New apps will let you track how much attention you pay to a certain problem or analyze an argument with your partner in detail. Hey, no need for people skills anymore, right? It's possible that scientists will find a way to increase the diameter of the neurons in the brain. That would give you an incredible reaction time, a real-life slow-motion function when you need to. With genetic engineering, more humans will look alike to fit the general idea of being attractive. There will be strong lines, straight noses, beautiful bright eyes, and all facial features fitting the golden ratio and perfect left and right symmetry. The brains will continue to grow, so there will probably be larger foreheads and maybe larger eyebrows to go with that. As it is highly likely humans will start living on other planets, we'd have to adapt to their harsh conditions. Lungs would have to be redesigned to gather more oxygen in new atmospheres. Tissues would have to change too to filter the dangerous elements of these different atmospheres. The further away humans will move from the sun, the dimmer it would be, and the larger the eyes and pupils would have to become. It would let them absorb more sunlight. They'd also develop new features like low-light vision and a sideways blink to help protect the eyes from cosmic rays. In 1,000 years from now, computers will become more and more human. To somehow compete with them, humans will become more integrated with robots. Tiny nanobots will swim around your body to boost all your natural abilities. Humans will be able to record sounds and have built-in phones in their ears along with super hearing. They will also have super eyesight and super health in general, which sounds quite nice actually. Merging human minds with computers will give everyone super brains. You'll be able to do the most complex equations instantly. Search the web and pull up any fact in your mind. You won't need to type any messages. You'll communicate with others through electrical signals and direct thought transmission. Humans will be an interplanetary species. Mars is the most likely new place of residence. New humans born on Mars will be taller than anyone on Earth. The Earth's gravity is 3 times stronger than that of Mars. Out there, the fluid between vertebrae would extend, making spines longer. Humans will most likely become immortal. To make it possible, scientists will have to figure out how to download consciousness into a machine. They are already trying to transfer consciousness between animals right now. Well, I can't speak for you, but for me, that's a bit of a nightmare. Hey, they can keep their nanobots. I'll just keep sitting here, watching the clouds go by and enjoying the sunshine. Like they say, it's not about the number of years in your life, but the life in your years, right?
Have you ever wondered how cool buildings of the future are going to look? Well, hold on tight because artificial intelligence is here to revolutionize the world of architecture. AI is a great sidekick. It can give the architects incredible new tools to create mind-blowing structures that are not only stunning, but also eco-friendly and super efficient. So let's check what our beautiful future might look like. First of all, you know how cities can get crazy busy and overwhelming, right? Well, guess what? AI is here to save the day and make our cities super smart. Imagine you're cruising down the road in your flying car. Yes, we'll have those. Thanks to AI, the traffic flows like a dream. No more endless gridlock. The city knows where the most likely crime spots are and takes proactive steps to keep us safe. It's like having superheroes on every corner. And hey, forget about trash piling up. AI makes sure waste is managed efficiently, keeping our city clean and fresh. They can act as a city manager who can optimize everything from traffic to safety and even waste disposal. They can analyze tons of data from all sorts of places like sensors and social media. With all that information, they can help city planners make brilliant decisions that make our lives better. Okay, so you stroll down the street and your eyes are instantly captivated by an extraordinary building. Its futuristic curves and features make it stand out from the rest. And it not only catches your eye, but also gives Mother Nature a high five. You might think it was designed by a genius architect, but little do you know it was actually a collaboration between humans and artificial intelligence. Imagine having a super smart design buddy who can whip up thousands of incredible building ideas in a blink of an eye. That's what AI-assisted design software does for architects. It can generate and assess a ton of design options. They take into account stuff like the best materials to use and the perfect placement for the building. Also, by analyzing data and crunching numbers, algorithms can help optimize the building's design. They can ensure it minimizes energy usage, conserves water, and manages waste like a pro. Every building strives to reduce costs, save energy, and promote a better world. The result? Architectural masterpieces that are both jaw-droppingly beautiful and super practical. The cityscape of the future will be dotted with these awe-inspiring structures. Oh, but that wasn't impressive enough for you? Well, how about a stunning, futuristic building that seems to defy gravity? It's not made of traditional bricks and mortar, oh no. This marvel was created using the powers of 3D printing. With the help of AI, architects designed every intricate detail and fed all the important data, like what materials to use and how the site conditions might affect the structure. AI algorithms worked their magic to optimize the design, making it both breathtakingly beautiful and rock solid. 3D printing is basically like having a magical machine that can create awesome structures straight out of a sci-fi movie, and AI jumps in to make sure these structures are not just pretty, but also strong. In the city of the future, 3D printing will become the ultimate architect's tool. It will allow them to create structures that were once impossible to build. From mind-bending shapes to intricate details, the possibilities are endless. But AI isn't just making buildings look great, it also makes them efficient and cozy. Let's say you step into a futuristic office building, and voila! The lights automatically adjust to match your mood, and the temperature is set perfectly for you. These futuristic buildings are capable of sensing and responding to their surroundings, just like you do. They control the lighting, keeping it just right for the time of day. They manage the temperature, so it's always cozy and comfortable. They even keep a watchful eye on security and fix small issues before they become big headaches. So, the smart building knows when people come and go, so it optimizes energy usage accordingly, saving the planet and some cash along the way. Now the cool thing is, all these aren't the only possibilities. How about turning skyscrapers into a vertical forest? Recently, an architect from India got super excited about the power of artificial intelligence. So, he decided to team up with an image bot called Midjourney to create a vision for the future. But instead of a dull, robotic world, they aimed for something spectacular. With text prompts like utopian technology and futuristic towers, the architect and AI got to work. Guess what? Midjourney didn't disappoint. It conjured up a world where buildings were covered in lush vertical forests and adorned with shapes inspired by nature. They wanted to create a sustainable future that harmonized with the environment. The architect, Manas Bhatia, is super positive about AI's potential. He doesn't see it as a threat to his job, but as a powerful tool for positive change. He envisions a future where architects and AI collaborate to make breathtaking designs. In his project, Bhatia even asked the AI to imagine symbiotic and hollowed structures, and it responded with pictures of apartments nestled within hollowed-out trees. Imagine a world where the building itself becomes a living, breathing part of nature. Well, Bhatia believes that nature should play a big role in architecture. He loves designing structures that embrace nature's beauty and functionality. From buildings built around trees to facades that regulate temperature, he's all about blending architecture with the natural world. With architects like Bhatia and the superpowers of AI, the future of cities is going to be amazing. So get ready to step into a world where nature and technology coexist in perfect harmony. It's a dream we can't wait to see come true. Or if you're not a big fan of trees, how about this? Skyscrapers that aren't made of solid bricks, but instead, they're inflatable wonders. Zumo, an architectural practice in Barcelona, used the magic of AI to bring these wobbly structures to life. These inflatable superstructures rise above future cities like illuminated balloons in the sky. Here's the best part. These inflatable buildings have sustainability superpowers. You can pump them up to towering heights, flatten them for easy transportation, and rebuild them wherever they're needed. Plus, they're powered by renewable energy, reducing their impact on the environment. Pretty cool, right? Phew. The future is zooming toward us like a rocket. Artificial intelligence can become the secret sauce that makes architects' work extra special. But hey, with great power comes great responsibility. We need to use AI wisely and ethically. For now, we don't have to worry about machines replacing architects. Artificial intelligence still needs a human hand, or else we might end up with buildings that look like mashed up bananas or ice cream cones, unless that's your thing. In addition, humans have one important advantage. They, well, are humans. We need to keep in mind that artificial intelligence doesn't have emotional intelligence. It's a brainy genius, but it can't fully understand the feelings and vibes we humans crave in our spaces. So, we must remember to infuse our designs with that human touch, those warm and fuzzy elements that make us go, "Ah, I feel right at home." And let's not forget that AI is still learning. It's basically just taking its first steps, and we need to be patient and give it time to grow. Rushing things too quickly could lead to wonky designs or buildings that look like a jumbled puzzle. This might look cool if you like avant-garde architecture, but for regular folk, no thanks. So, as the future unfolds at warp speed, let's embrace the wonders of AI in architecture. But let's also remember to balance its brilliance with our own human touch. Together, we can create a future where buildings are not just functional, but also filled with heart and soul. It's an adventure that's out of this...
Traveling back in time now, this used to be hard. We fly past the Middle Ages, the first human civilization, the ancient ancestors of the first humans, the dinosaurs, the first land animals, the ancient sea creatures, and so on to the very beginning of all time. And there it is. This nebula is our solar system. Right now, it's just a cloud of multicolored dust made of hydrogen and helium spinning around. This cloud has begun to shrink and become denser. There's a theory that there were supernova explosions near our nebula. Their shockwaves squeezed the nebula from different sides until the center of the cloud became too heavy. The enormous weight presses it, and nuclear chain reactions begin at the very center of this cloud. It heats the cloud and makes it glow. Soon it forms into a dense sphere, and that's how our sun is born. It happened about 4.5 billion years ago. Our planet doesn't exist yet. There's only a disk of dust and space debris orbiting the young sun. These pieces of debris are fusing gradually and getting heavier and heavier. Let's look at the very center of this pile of asteroids. The total weight of the debris compresses the central region so much that a dense metallic core is forming there. The enormous pressure heats the core, and the temperature at the center of the young Earth reaches nearly 10,800 degrees. And there's a liquid core around the solid one. It creates the magnetic field of our planet. Now, when radiation from the sun and the solar wind reaches Earth, it smashes into a shield in the form of our magnetic field. So far, our planet is burning and looks more like a ball of lava. But it begins to cool down, forming a solid crust. At this point, another protoplanet appears on the horizon. It looks more like an asteroid, the size of Mars. And this massive piece of debris flies towards us. It hits the young Earth at such an angle that it knocks a part of our planet outward. The debris itself breaks into several pieces and stops in our orbit. After a while, all of this debris comes together to form the Moon. As a result of this collision, the Earth began rotating too fast. A day now lasts about 5 hours instead of the usual 24. But the Moon is heavy enough to slow our planet's rotation with gravity. Now, the Earth doesn't look like a hospitable place. The gravitational forces of the Moon are penetrating deep into the Earth and causing more volcanic activity. Also, meteorites are constantly falling here, causing frequent explosions on the surface. Ow! The gas that comes out of the volcanoes forms our atmosphere. The ice that was brought to our planet on meteorites evaporates. The vapor rises and turns into rain. This rainwater falls to the surface, cooling the hot lava and forming the first lakes and rivers. For several hundred million more years, Earth resembles the surface of Venus. It's a lifeless place with a bunch of volcanoes, acid rains, and no oxygen to breathe. The sun wasn't as bright as it is now. Plus, the sun's rays could barely pass through tons of volcanic dust in the atmosphere. But about 3.5 billion years ago, the first life appears here in the form of single-celled organisms that didn't need oxygen. They appeared in the shallow, warm parts of the ocean near the shore. These bacteria reigned on Earth for nearly 2 billion years throughout the Archean eon. They left stromatolites. These are stone pillars at the bottom of shallow warm water. They're the product of simple organisms and bacteria. These bacteria evolved until they learned photosynthesis. Bacteria began to produce oxygen by absorbing the energy of sunlight. At first, this oxygen was spent on oxidizing rocks, but then excess oxygen began to fill the atmosphere. Plus, at this time, the first algae appeared, which also produced oxygen. This event is called the Great Oxidation Event, good name, which caused almost all living organisms to disappear from the face of the Earth. For simple organisms, oxygen was toxic, and the remains of bacteria and microorganisms sank to the bottom of the ocean. Many millions of years later, these remains will be recycled, and under the tremendous pressure of water and the Earth's crust, they will turn into oil. The Archean eon ended with this catastrophe about 2.5 billion years ago. At the same time, continents were forming on Earth, which would later drift through the world's oceans like puzzles and form a supercontinent. But for now, methane and carbon dioxide still make up most of the atmosphere. They cause the greenhouse effect and the rising temperatures on Earth. But the emergence of oxygen stops the greenhouse effect, and the temperature on our planet drops. An ice age, the so-called Huronian glaciation, which lasted from 2.4 to 2.1 billion years ago, begins. Scientists speculate that our planet was almost completely covered in ice at that time, even on the hot equator. A huge change when you consider that 2 billion years ago, our planet was like a ball and lava, but now it's like a block of ice. Earth, during the Huronian glaciation, was more like Jupiter's satellite Europa. There, too, is a thick crust of ice, under which there's a liquid ocean heated by the core. The evolution of the Sun saved our planet. Since its birth 4.5 billion years ago, it's been getting bigger and hotter. So, after 300 million years of an ice age, the Earth began to warm up. But almost all life there had been wiped out, and evolution has to start all over again. About 1 billion years ago, all of the continents of our planet were assembled into one hypothesized supercontinent, Rodinia, and all the oceans made up one colossal ocean of Miravia. 750 million years ago, that continent broke apart and huge chunks of land began drifting across the planet. Complex plants and multicellular organisms appeared just at this time. Algae, sponges, and fungi weren't the only inhabitants of the ocean. This is Sprigina. They're a kind of worms the size of a human finger. We have remains of these animals that are at least about 550 million years old. 541 million years ago, the Phanerozoic eon began. The main event at that time is the Cambrian explosion. Life began to blossom on Earth, and a great variety of living organisms appeared. Mollusks and echinoderms like starfish and sea urchins appeared. Living organisms evolved, having not only an internal but also an external skeleton, like trilobites. Some of these things could reach nearly 3 feet in length. Their protective shells suggest that there were predators in the ocean. A food chain started forming at that time. At the same moment, the drifting continents fused again. This supercontinent has a different shape and is called Pannotia. Later, these continents drifted apart again and began to collide with each other. This led to the formation of mountain ranges. Then the continents met for the last time and formed the giant supercontinent Pangaea about 335 million years ago. Here we can already see the outline of the modern continents of Africa, North and South America, Australia, and Eurasia. One of the largest sea creatures ever, the Dunkleosaurus, appeared. Some individuals could be as long as a school bus and weigh as much as a large SUV. The land had a hot and humid climate. It encouraged ferns and other plants to grow faster. Some of them could reach the height of a 3-story building. And for the first time in Earth's history, some animals leave the ocean and go on lands, such as L. generpeton and Ichthyostega. Anyway, at first, they live only on the coast because their skin wasn't adapted to the constant sunlight. In addition, they experience breathing problems. The first animals on land had both gills and lungs, but the lungs were underdeveloped, so they had to return to the water. Millions of years later, these animals evolved into more advanced amphibians. Though they were no bigger than ordinary lizards, they could already live fully on land. But this blossoming of life ended in a new ice age. Glaciers from the poles slowly crept toward the equator. Animals weren't prepared for this, and most of them didn't survive this extinction event. But 290 million years ago, evolution retook hold and more evolved land animals began to appear. Gradually, they increased in size, multiplied, and gave birth to a new species like Scutosaurus and Gorgonopsis. But this period didn't last long either. Only 40 million years later, as a result of unknown events, 95% of all living organisms on Earth ceased to exist. It could have been caused by a giant meteorite or by increased volcanic activity. Also, one hypothesis says it could have been the release of methane from the bottom of the ocean. The Mesozoic era began after this extinction. This is where the dinosaurs, as we know them, appeared and started a new page in Earth's history. So here's the scoop. You're not even born yet, but your parents already know what you're going to look like. In the year 3021, DNA tech is so advanced they can basically pre-program a person. Eye color, hair, face, and nose shape, lips, finger length, body structure – it's as simple as selecting from a drop-down menu, kind of like creating your own character in an RPG. Everyone looks great. No more diets, no more gyms, and a healthy body for everyone. All it takes is a little gene modification and a special liquid full of a couple of million nanobots. Bioengineering and medtech allow people to change their bodies and minds whenever they want. Improved hearing? Done. Now you can hear a fly rub its paws together from the other side of the room. Not that you'd want to. Nanorobots can turn your eyes into binoculars with 100 times zoom. From your 160th floor apartment, you can read the nutrition info on that wrapper lying on the ground. You've got to get a life, pal. Want to fall out of a window and land unharmed? Nanorobots can make it happen. Millions of tiny robots can be sent to cover your bones and muscles if you want to lift a car with one hand. Superheroes aren't really a big thing anymore. Anyone can get superpowers in 3021. And say goodbye to spending years learning a new profession. You don't need to go to college to find a good job. Just download all the skills and knowledge you need. Medical nanorobots can get into your brain and improve your mood. You can become joyful, angry, funny, sad, all in a matter of seconds. The physical brain isn't a mystery anymore, nor is the subconscious mind. That means no more psychologists or psychiatrists. And solving your personal problems? Easy. You have special lenses built into your eyes linked to AI. You can see an analysis of your mind, and AI will even suggest a strategy for improving it. Not getting enough vitamin C? You'll get a notification. Need more protein? Notification. You'll get it. It's awesome! Amazingly, nanorobots open access to your memories. Watch them like movies, any period of your life, anytime you want. You can see happy moments in perfect detail, or permanently delete anything you'd rather not see anymore. Genetic engineering makes it possible to create not only modified humans, but also animals. Scientists bring back extinct fish, birds, and mammals. You can even grow your very own pet from scratch. A dog, cat, small elephant, dinosaur, whatever you want. And if you don't like cleaning up a mess, pick up a pet robot that looks and acts just like a real animal, without all the annoying stuff. In 3021, your body can live for 200 years, but your mind, forever. You can upload your brain data to the cloud. Your way of thinking, habits, attitude, character, memories, your entire personality can be coded and uploaded. You can encode your mind now and download it into a new, modified body, say after you hit your 189th birthday. And this new body doesn't need food or water, only energy. In the future, no one goes hungry. People travel around the galaxy in style. You can upload your consciousness to a computer and beam it over to your other biomechanical body that you had shipped to another planet. If you've got enough money, you can buy several bodies and scatter them in different parts of the galaxy. Then, on your day off, you can teleport your mind to another planet just to get a bit of peace and quiet. If you want to unload your consciousness and download it again in a few hundred years, you've got a choice to make. Be in a 100-year-long dream, or spend the time flying around in an infinite network. You can even put your mind on the internet and do whatever you want. Some people even choose to live inside the web just for a year or two. Matrix, anyone? People have learned to change their surroundings with the help of utility fogs. Imagine a robot the size of a human cell. This robot has several limbs, can change color, temperature, and can connect with other tiny robots. Utility fogs are just trillions of these little guys. They cling to each other and can create any object you want, or they can turn into a sort of hologram, perfect for video calls. The fog can take on any shape. It can be a cup, a painting, a car, a bigger robot, just not anything living. But just because it's the future doesn't mean everyone gets to have fun. This fog tech is crazy expensive. The fogs can create buildings. You can wake up in your beautiful house, go to work, and the house gets automatically folded up and transformed into a small suitcase. Hey there, George Jetson! You can travel around the galaxy with it and transform it into any home you want. Suddenly feel like having a bigger kitchen, different furniture, a rooftop pool, a slide from your bedroom to the kitchen? No problem. And inside your house, things are way different. You don't have to clean up anymore. Dust, dirt, and grime are all taken care of by nanorobots. You're watching a sad movie, crying, going to town on a Kleenex. Then you just toss the used tissue over your shoulder. Right where it lands, your utility fog turns into a small trash can with wheels. It zips over to the kitchen, dumps out the Kleenex, and poof, it disappears. What about an after-movie snack? For centuries, pizza drones have been flying through the streets. At one point, it got a bit ridiculous. There were too many of them. They started crashing into each other and into passing birds. Now, you just order a sandwich or pasta through your special lenses, and the food gets 3D printed. When resources on planet Earth began to run out, people colonized the Moon and Mars. Then, the big breakthrough – a thermonuclear engine, capable of transmigranuclear flabba. Hey, let's just call it a teleporting device. People sent AI robots over to build cities, roads, electrical grids, and water filtration plants. Then, people began to move there permanently. Everyone born on Mars or the Moon was different from us Earthlings. Mars, for example, gets less sunlight than Earth, so Martians have wider pupils. That means if they ever come back to Earth, they'd basically have night vision. But Martians, and people on the Moon, lunatics? Have weaker bones. Luckily, they have those handy nanorobots to help them. But with these new discoveries come new risks and dangers. Uploading your consciousness can go horribly wrong. You risk facing virtual viruses that can imprison you in a virtual cage. Many attackers use programs that can erase your mind, just like a plain old file on your desktop. Those nanorobots, they can still be defective sometimes, and instead of upgrading your body, not great. Moving to other planets is crazy risky. We sometimes have to abandon cities on Mars because there's suddenly a 300-year-long dust storm. And space travel, sorry to tell you, never stops being dangerous. Even in 3021, there are loads of forces in the universe that scientists still don't understand. Say you buy a modified robo-body and send it to a beautiful new Martian city. You're on Earth, and you upload your consciousness to a computer and send it on over to the new body. The weather is perfect, the sunsets are epic. Suddenly, a huge asteroid smashes into your house. These kinds of things happen in 3021. The way we live now seems exotic to the people of the future. To breathe and live in a natural body, to eat natural food, to take a real water shower, to learn new info by reading. That stuff freaks them out. At some point, humans learn to travel through time, but immediately ban the new technology. Humanity's living in a utopia, apart from the occasional asteroid ruining that robot body you saved up for a whole year to buy, and any change in the past could mean the end of it. Instead of traveling to the past or the future, people create virtual simulations of their favorite time periods. The most popular simulations? Just going back in time and living a day as an ordinary person in 2021. Powerful quantum computers analyze your genes, calculate what you would have looked like, and recreate an exact you. Life was so much simpler 1,000 years ago. Me? I'm going to 1977. Disco, the Bee Gees, glitter balls, the golden age of music. For some of us.
The most incredible technology for transporting things and people could be teleportation. Unfortunately, we won't see a teleportation machine in the near future. But we will be able to ride perfect self-driving cars with autopilots on the road and in the air. We will also ride flying motorcycles and take a vacuum train to get from New York to Los Angeles in just a few minutes. So, let's start with self-driving cars. The principle of operation of almost all such vehicles is the same. The car has cameras and sensors, high-precision maps, and radars that scan the situation on the road. A common system unites such machines. Each of them knows where the others are, and this prevents accidents or traffic jams. Of course, today's cars with autopilot are not so impressive. Many people drive them. But imagine what will happen when all vehicles on Earth get united by a common artificial intelligence. People will forget about traffic jams forever. Computers will predict dangerous situations and prevent them. But what will people do on the road if they don't drive cars? The developers will focus on passenger entertainment. The car will be able to tell you the exact time of the trip. Do you need to arrive at noon sharp? Okay, the car may intentionally slow down or increase its speed. It will turn into a real electronic assistant. You can have a meeting, order food, and choose a movie with the help of voice control. The driver's seat has a mini movie theater, a game console, or a mini refrigerator. People who like to communicate with drivers will be able to speak with advanced artificial intelligence. But, of course, there will also be problems. The main one will be the excessive correctness of driving. Scientists and developers are working on humanizing machines. Here's an example. Let's say the car is driving along a busy street and notices a man standing by the road. The car's internal system quickly analyzes the situation and decides that the person is going to step onto the road. The only reaction of the computer is to pull over. The car is slowing down. Another car stops behind it. The first vehicle has created a dangerous situation and a traffic jam. And the man was not even going to cross the street. He was just standing there, waiting for his friend. Deal with this issue. The developers of some companies equipped their cars with a voice. That is, they taught them to honk. In a problematic situation, such a vehicle will press the horn like an angry driver. But the car can slow down if a bird flies by. No horn signal will save you here. On the one hand, the human factor is one of the main causes of road accidents. On the other, a person can analyze a situation much better and choose the right solution. It's unlikely that a machine on autopilot will stop to pick up a guy hitchhiking on the side of the road. Perhaps this guy has gotten into trouble and he urgently needs to leave that place. Or maybe he was bitten by a snake and he needs to go to a hospital. The computer can't know that, but a kind person behind the wheel will stop and offer help. Even if the world gets rid of traffic jams, people will strive for something more, whether on the road or in the air. Many engineers believe that autonomous flying taxis and buses are the future of transport. But gravity-powered flights will appear in the distant future. Such machines will work on the principle of a helicopter. They will be stylish small helicopters equipped with autopilot. Uber and other companies are investing in such technologies, and you might soon be able to use them. Let's say you're late for some event. You open the app and book the helicopter closest to you. Next, you go to the roof, where many aircraft are parked. Then your pilot takes you to the parking lot of your destination. And from there, you quickly reach the location you need. And imagine the same thing, but for many people at once. You arrive at a particular train station and get on a bus with wings. It takes off and follows a long route, taking you and other passengers to another city. And what if such giant buses could take you into space? Not only cars will have propellers, but also motorcycles. There are already hover bikes designed for one passenger. You put on a helmet and sit on a small device. In 2025, you will be able to buy such bikes for $50,000. Unlike flying cars, hover bikes cannot take off to a great height or accelerate to high speeds. But in the future, this technology will evolve. Air taxis and autopilot cars only work in the air or on smooth roads. But what if you need to cross an area with a mountainous landscape or swamps? For such off-road areas, Hyundai has developed the coolest SUV. Instead of wheels, it has legs. This walking vehicle passes through difficult sections and does it with maximum comfort. Each leg has knees and can bend. It will take you to a high hill or even to the top of a volcano. Soon, you won't need to go shopping because stores will come to you. Toyota has already created an unusual car you can turn into a store with any goods. Clothes, groceries, toys, jewelry, whatever. Such vehicles could improve delivery services and provide more comfort to people on trips. But the most incredible technology that will appear in the future is the Hyperloop. It's a train on an aerodynamic cushion. Imagine a capsule traveling at a speed of 760 miles per hour inside a vacuum tube. The interior resembles a spaceship capsule. You take your seat and fasten your seatbelt. Right now, you're accelerating to a speed that exceeds the speed of sound. But inside the cabin, you don't feel this speed. If you watch this train from the side, it will pass by you faster than you blink. And that's how it works. You know air hockey, right? The puck easily flies through the entire area because small holes all over the field release a thin layer of air. The puck doesn't touch the field itself, it levitates. There's no friction, so it just moves around the area. The Hyperloop works on a similar principle, but the air is coming from the capsule, not from the tube. Thus, a tiny distance appears between the capsule's walls and the tunnel. And with the help of an electric motor, the train is set in motion. Okay, we figured out the friction force, but what about air resistance? The fact is that at very high speeds, large objects can't move quickly if the air is very dense. You literally crash into the air, and it limits your speed. Standard airplanes fly at an altitude with much lower air density to develop high speed. That's why the Hyperloop will move inside the pipe. Special equipment pumping the air out of this pipe will work on certain sections of this route, but some air will still be there since creating a complete vacuum requires a lot of energy. A special fan on the train's nose will move all the incoming air under the capsule. The movement of a vacuum train resembles the work of pneumatic mail. This is when parcels pass through pipes installed in a building, and these parcels move through the pipes thanks to air compression. The Hyperloop should work using solar panels installed on the roof of the pipe. Elon Musk has long come up with this idea, but its development has some difficulties. The air gap between the tube and the capsule must always be the same. Any pipe crack, bump, or stone can destroy the entire structure. What if a small earthquake happens somewhere? But if engineers manage to develop this technology, we will be traveling from Los Angeles to New York in just a few.
You're inside a small spaceship. You're flying higher and higher, then leave the atmosphere of our planet. Hundreds of thousands of satellites with glowing advertising banners appear in front of you. One of them says, "Happy New Year, 5699. This year you have an anniversary. You will be 5,000 years old. You press a button on the touch panel and activate the ad block. Now you can't see any holographic banners through the glass. You're going to make a jump through space. A black tunnel called a wormhole appears in front of the ship. You fly inside and the hole disappears. The ship has teleported to the Andromeda Galaxy. You discovered an exoplanet here recently, similar to Earth. It's also blue, has a lot of water, but only one huge continent. The planet is hidden in dense interstellar clouds, and you hope that other people won't find it soon. But as soon as it's entered into the Intergalactic Register, you'll definitely buy this planet. You call it second home. Now you're flying into the atmosphere, going through the clouds, and landing on a small green hill. At the foot of it, you see several small houses made of clay and stone and thatched roofs. Near the houses, locals are working in simple clothes. They're plowing the ground, and cows are eating the grass nearby. You have turned on your stealth mode, so the locals can't see you. They aren't real people. You created them using cloning technology. The conditions on this planet are now the same as they were on real Earth in the year 699, the year when everything changed for you. You remember swimming in the lake at night and looking at the stars. One star moved from its place and began to approach. A huge flash of light and something heavy fell into the water. You lost consciousness and woke up in the morning on the shore. Only 1,000 years later, you realized it was a meteorite. The day after the star fell, you noticed that any damage on your body instantly disappeared. After a couple of decades, you realized that you get older slower than the rest of the people in your village. After another 50 years, you understood that you didn't age at all. Knights, Vikings, the Dark Middle Ages, the geniuses of the Renaissance. You see it all with your own eyes. You become an emperor of a huge empire, and then you get bored and decide to live in the slums to feel all the shades of this life. You think that some magic gave you immortality, but then you realize that any magic or sorcery is really science. You communicate with the greatest minds on the planet, make friends with incredibly bright people and really bad ones to understand the nature of humans. Around the 15th century, you've got all the knowledge and read all the books that people could give you by this time. You begin to explore the world yourself. You discover the process of photosynthesis in plants, grasp the fundamental laws of physics, conduct amazing chemical experiments, and find out that you live on a tiny planet in an infinitely vast universe. Biology, chemistry, physics, astronomy, you learn and explore everything. The results of your scientific research in these subjects are ahead of humanity by 100 years. While the whole world is riding horses, you're already building a car with a steam engine. To hide your identity from people, you constantly change your name and place of residence. Over 1,000 years, you have learned all the languages of the world, and even those that no longer exist. You study all the psychologically known personality types. Your social and emotional intelligence is so developed that you can create a person's portrait after 1 minute of talking to them. You look into their eyes and understand what they want, are afraid of, or are ashamed of. You spend several years in continuous meditation to calm your mind and gain wisdom. You lead the life of a hermit and watch humanity slowly develop. But then, the 20th century comes, and the life of the entire planet changes dramatically. The Industrial Revolution, the first cars and trains, cinema, radio, and television. In these 100 years, people are changing more than they have in the previous 1,500 years. Now, it's hard for you to keep up with the world. New inventions appear every day and every hour. The knowledge and experience of previous years help you become one of the most influential people on the planet. World leaders listen to your opinion. Thanks to your developed communication skills, you can negotiate with any person. You go through expensive and high-quality plastic surgery operations so that no one will recognize you. You keep moving and getting a new ID every 20 years. You have a lot of money, as well as gold and other valuable metals that you've collected for centuries. You build houses and shelters in the most beautiful places on the planet. You finance the development of new technologies. Sometime in the 1950s, you predict that in the next century, there will be a unique network that will allow you to store all the knowledge of the world in a small device. With the help of this network, all people will be able to communicate with each other from different points of the Earth. You're surprised that the internet appears much earlier. Developers create virtual reality worlds with photorealistic graphics. Artificial intelligence is smart enough to rule a small country. Genetic engineering allows us to clone people and mix our bodies with robots. The first cyborgs appear. With each passing century, there's less and less space on the planet. You get tired of people and consuming new technologies, and you spend more and more time in your home on the top of Mount Everest. Humanity is taking over Mars and the Moon. Soon, these places aren't enough for people too. In the fourth millennium, scientists create a quantum engine to travel through space. You're among the first people to try this technology and make the jump to another group of planets orbiting a star similar to our solar system. Your ship breaks down and you can't go back. You're left to live alone on a new planet. Your body adapts to the conditions on it, so you don't need oxygen reserves. Then, you learn to breathe without oxygen at all. The cells of your body receive what they need for normal functioning from the surrounding gases. Your skin is getting rougher because of the dusty atmosphere of the planet. And with the increased gravity, you develop incredible strength. You'd become a super person with such a body on Earth. You manage to send a signal into space, and you hope that humanity will catch it. You've been living alone for over 500 years without books, the internet, or any communication. You spend most of the time exploring a lifeless desert world. Using parts and tools of the ship, you create a vegetable garden. You also have a lot of water reserves. During all this time, you realize that you miss the old world and your life before the meteorite fell. Some spaceship picks up your signal and comes for you. You return to your homeworld. Travel between solar systems is now as easily available as travel by subway or bus. You decide to find a planet as similar to Earth as possible to recreate human life there. Using the power of modern telescopes and your knowledge of astronomy, you discover what you've been looking for in the Andromeda Galaxy Nebula. You arrive at the second home and live a human life there. For hundreds of years, you observe people and mentally go back to your past. You protect those people from external threats, like asteroids, but don't interfere in their lives. From time to time, you fly to Earth and other planets for business. Life on the second home is becoming very similar to life on Earth. There are more and more people and cultures. Technologies are emerging. You have completed your goal, and now you want to discover other worlds. You spend the next 5,000 years studying the ever-expanding universe.
Imagine that it's the year 2025, and our planet has completely changed. Rising sea levels, extreme weather, and the ocean becoming more and more acidic are just some of the problems people have been dealing with for years. But in one of the world's largest coastal cities, the situation has become too serious. It was a sunny day in June when a massive earthquake shook the city to its core. The ground beneath people's feet heaved and shook, and buildings swayed dangerously. People ran through the streets in panic, trying to find safety. But as soon as the ground settled, the inhabitants of the city realized the real danger. A wall of water, almost 100 feet high, was rushing toward the city, propelled by the force of the earthquake. The tsunami hit the city with unimaginable force. Entire neighborhoods were wiped out, and thousands of people lost their lives. But here's where things get interesting. In the aftermath of the disaster, the city's authorities realized that they couldn't just rebuild the city as it was before. They needed to be better prepared for the next potential disaster. And so they came up with an incredibly ambitious project to build an underwater city. The goal was to create a self-sufficient, sustainable city beneath the ocean's surface that could withstand any natural disaster. The underwater city would be powered by renewable energy, using tidal power and underwater solar panels. It would be designed to withstand extreme weather and would have its own emergency response systems. The project attracted some of the world's top scientists, engineers, and architects. They worked tirelessly to design the city and carefully considered every aspect of the project. The underwater city would have everything that a typical city had, from schools and hospitals to stores and restaurants. There would be underwater farms where fish and other marine creatures could grow. The city would even have its transportation system, advanced submarines, and underwater tunnels connecting different parts of the city. The project became a shining beacon of hope for people. It showed that even in the face of disaster, we could come together to create something amazing. But as time went on, the project no longer seemed so perfect. The cost of the project turned out to be higher than planned. There were also concerns about how long such a project would exist. After all, the ocean is very unpredictable. And still, the team of scientists and engineers never gave up. After years of trial and error, they finally created the perfect underwater city, a marvel of engineering, a self-contained ecosystem that could sustain people indefinitely. The buildings were constructed from a material that could withstand the immense pressure at the bottom of the ocean, and the city itself was powered by a network of advanced hydroelectric turbines. It wasn't long before the first wave of colonists arrived at the underwater city. There were different people in this group, and each of them had their own reasons for choosing to live in this new world beneath the waves. Some were adventurers seeking a new world to explore, while others were hoping to escape natural disasters raging on dry land. But despite their differences, all these people shared a common goal: to build a new society, one that was in harmony with the natural world. The underwater city flourished, and new discoveries were made every day. The colonists developed new technologies and ways to tame the power of the ocean. They learned to farm the sea and started cultivating underwater gardens that provided them with a steady food supply. But living underwater was challenging. People felt isolated and even claustrophobic. The situation came to a head when a group of activists started to protest against the city's expansion plans. They argued that the underwater city was a threat to the environment it was meant to protect, and that the colonists should focus on reducing their impact on the delicate underwater life. The protests sparked a heated debate among the colonists. Some of them argued that the survival of the city depended on its growth and expansion. Others claimed that the city needed to prioritize the protection of the environment above all else. In the end, a compromise was reached. The city would continue to expand, but the main priority would be sustainability and a responsible attitude to nature. The colonists would do their best to reduce their impact on the environment by using new technologies and following strict conservation rules. And they would also remember the importance of protecting the ocean and its fragile ecosystem. Years went by, and the underwater city continued to thrive. New generations of colonists were born, and they grew up in a world entirely different from the one their ancestors had known. They never saw the world on the surface, but appreciated the beauty and complexity of the underwater world they called home. And as the years passed, the city became a symbol of hope for a world struggling with the devastating effects of climate change. It showed that despite all difficulties, people could come together to create a better world. It is a reminder that the future is not set in stone, and that we can build it sustainably and in harmony with the natural world.
You were lucky to find that 6-by-6-foot apartment after all. None of your friends own one. They mostly live in capsule modules where it's only possible to sleep without turning and tossing much. The price for what they call a mansion today is obscenely high, and you still fully can't accept it. Tomorrow, you gotta sign that contract and make the down payment. Actually, you had the chance to buy it only because you won that chance in the lottery. This is how you live in $29.99, you and the other 100 billion people. Some people, though, invest in numerous new millennium apartment blocks on other planets. The latest real estate trend is to downshift somewhere on Ross 128b, Mars, or even Saturn. You were thinking about it too, but you just love the Earth's atmosphere and nature too much. While you're sipping your morning coffee, a pop-up advertisement hologram instantly fills all the space in your capsule, and it just won't disappear. Dear Earthen, don't miss out on the chance to change your life once and for all. Check out the newest apartment blocks on Ross 128b, Mars, Europa, and Saturn. Invest in your new housing and brand new life. Bus tours available daily. Suddenly, you realize this spam might be your chance. You still have some time before signing that contract. You've got nothing to lose. It's just a one-day tour. After all, 11 light-years from Earth to Ross 128b aren't a big deal now. Just a couple of hours on that space bus the agency provides. You'll go there and see that there's no place like Earth, just to make sure you've made the right choice. You rush to the space bus station, and you're just in time. 3, 2, 1, go. The bus pulls out, and 2 hours later, you're already there on Ross 128b. Wow. It looks like a bit of old-fashioned Earth you've seen in scientific presentations at university. The surface is rocky with some green spots. These must be the forests and meadows scientists are trying to introduce. It does have an atmosphere, although artificial. The real estate agent says it's actually good. No unpredicted weather anymore. Everything is controlled by the dwellers. The only inconvenience is that the better the weather is, the heftier bill you're going to get next month. The UV protection is essential on Ross 128b. Its index is 38% higher than on Earth, so a regular sunscreen turns out pretty helpless. They say this planet is like the Earth twin, but you kind of disagree. There's some vegetation, but it all looks so weird, you feel like you're in a computer game. Next to the apartment block, there's an orchard and a small farm producing organic food for the locals, so you decide to pop in and check how it works. The fruits and vegetables look so odd there. You realize this must be an apple tree, but it has microchips instead of flower buds, and the fruit are cubical. There are apples of all of the rainbow colors. You go forward and stumble on a small rock, one of the few things that belonged to this planet originally and weren't imported from Earth. A butterfly lands on the tip of your nose. You want to touch it, but as soon as your fingers reach it, the insect disperses in numerous pixels. The real estate agent runs up to you, helping you stand back on your feet. She says all the fauna on the planet is still represented in a form of holograms, because transferring it all from Earth doesn't seem possible at the moment. All the fauna elements are tightly connected together, and even the smallest butterfly can make a dramatic difference. With the money you have for the down payment on Earth, you can afford a 2-story apartment on this planet. The only problem is tiring commuting to work every single day. Come on, y'all, Mars is ahead. We still have a lot of apartment blocks to show you. Ah, that's the real estate agent calling you. You hop on that bus and sometime later you land on Mars. By $29.99, it looks just spectacular, but a bit too sandy. The scientists still can't bring liquid water to this planet, even though the atmosphere is completely fine. The planet's too warm now because they tried to make it habitable. Even though there are glaciers, all the water instantly turns to gas because of the heat. You spot some large machines up in the sky. The real estate agent says these are some essential pieces of equipment that trap the gas water up in the sky to make Martian pouched water. She hands one pouch to you to try it out. Looks like an air balloon. Weird. You inhale it and you've never tasted anything like this before, and you still can't understand how that gas quenched your thirst. The main plants on Mars are cacti of all forms. They adapted perfectly to its atmosphere, and scientists even managed to blend other plant genes with those of cacti. These tall plants are a Martian type of maple. You can tell it looking at the leaves. Here, there are some pears growing on that large cactus, and you can see mangoes, avocados, and fruits of all kinds. They seem to be thriving. The sun's shining, and they're surrounded by water in the form of gas. It almost feels like home here. While Ross 128b still has to be developed, it's been over 200 years since the first ranch on Mars was made. The real estate is pricier here though, so you can only afford a nice studio apartment. Looks like a bargain, but it's time to visit another planet. You're headed to Europa, one of Jupiter's moons. You've been to this planet last year on vacation, and you loved it a lot. 1,000 years ago, the scientists thought there was water under its icy crust, and they were right. The crust melted, forming a huge ocean twice the size of Earth's world ocean, and the planet itself has been undergoing various changes over the last millennium. All the cracks it had on its smooth surface formed many small continents. All of them were named after European countries, but you have enough time to visit only one of them, Italy. The continent is surrounded by azure water, and there are endless fragrant lemon trees. People cook pizza with freshly grown tomatoes, though they're as large as Earth's watermelons. One tomato is enough for 2 pizzas. You look through the Europa brochure to get more information about other continents. On Norway, there are mountains looking very much like Norwegian fjords. On France, there are endless lavender fields. And on the continent of Greece, there are large farms with olive trees. You close the brochure, realizing that real estate here is almost as pricey as back on Earth. No wonder too many people want to live there. Time's up, you've got one more planet ahead. The bus is about to land and there's an announcement. Welcome to Saturn. Put on your swimming masks and dive in to see our ultimate apartment block. The scientists spent over 250 years trying to solidify Saturn, but it was in vain. In the end, they decided to try making the first settlements back in the 2980s when you were a kid. The gravity on Saturn is a bit stronger than on Earth, which allowed scientists to construct large complexes under domes for people to dwell there. In the depths of Saturn's gas oceans, there's a wide variety of fauna – jellyfish, octopuses, even sharks. They look a bit different, trying to adapt to their life on another planet. Their fins look way larger to help them handle incredibly strong winds of 1,100 miles an hour. But the most incredible part is the flora. Saturn's algae come in at least 3,000 different colors, at least the brochure says so. You can also regulate their intensity and shade with a remote. 2 hours later, you're back in your capsule. You keep tossing in your bed, it's the last night here. Tomorrow is the big day, but you're still in two minds. You saw that studio apartment on Mars in your dreams. You ate Martian pancakes topped with cactus maple syrup. The alarm goes off. Congratulations! You're now the owner of your own apartment on Earth. Very few people can make it in $29.99, Mr. Sanders. You're holding a set of keys in your hand. A notification beeps on your phone. Lease your apartment on Earth and move to Mars. You won't ever have to work again. You can't help it and begin to smile.
Look up when the sky is clear at night. You'll see thousands of tiny bright dots there. It may seem like they're fixed in one spot, but in reality, they're constantly moving. In 100,000 years, there won't be a constellation with the same shape or pattern we know today. And think about all those red dwarfs, small stars, planets, space bodies we can't see with the unaided eye. Red dwarf stars are especially cool. They're usually about half the size of our sun, and mostly 1/10 as bright. They may not be the brightest things in the sky, but they live for a very, very long time. Nuclear fusion reactions happen deep in star cores. That's what makes them shine. Large stars release huge amounts of energy, burning their stellar fuel. But such stars tend to burn all their fuel in only a couple of million years. Stars like our sun usually live for about 10 billion years, but red dwarfs don't use that much of their fuel. Their light is not so powerful, and they don't require much energy to support their existence. They're like energy-efficient cars. That's why they can last hundreds of billions of years. Some of the smallest ones may live for up to 10 trillion years. Most hydrogen in sun-like stars remains unspent. There's more of this gas in the atmosphere rather than in the core of such stars. This means most hydrogen doesn't take part in the fusion reactions. But it's different with red dwarfs. They circulate plasma throughout their entire bodies. These stars pull fresh hydrogen reserves from their outer layers into their core. That's what keeps fusion reactions running. One day, in the distant future, stars like our sun will run out of fuel and shut down. The universe will be full of small red dwarfs. They won't have enough energy to shine and brighten the space around them. Our descendants, if there are any, will inherit a dim, dark cosmos. As it gets older, the sun will balloon to a size where it will destroy nearby planets. First Mercury, then Venus, and then us. On the other hand, Earth will probably survive, but barely and not for long. The sun will burn it to a crisp when it gets closer. The outer planets of our solar system will also survive, but they'll move even farther away into space. The sun will lose some of its mass while increasing in size. Its gravitational pull establishes the orbits of the planets. When our star becomes less massive, the pull of its gravity will become weaker, and the outer planets won't have such a strong connection with the sun. Our solar system is not isolated. There are many other stars in our galaxy. Within 30 billion years, stars that travel nearby will mess with our outer planets, enough to rapidly launch some of the biggest ones out of the solar system altogether. The last planet to stay will stick around for a while longer, maybe even 100 billion years. But even that one will eventually end up kicked out of the solar system. There's a theory claiming that we got most of the water on our planet from ice-laden meteorites and comets, frozen balls of ice and dust. As they crashed into the early Earth, they probably brought water, which was necessary to develop life. But those very same objects that might have created life on our planet could also be its end. This is not a matter of if, more a matter of when. And scientists think it's very likely that an asteroid or comet big enough to wipe out life on Earth will smash into our planet. But it'll happen in the distant future. And fortunately, we have the technology to predict such things and react on time. But there are other cosmic collisions we can't avoid, no matter what we do. Andromeda, our neighboring galaxy, is moving toward the solar system at a speed of 68 miles per second. There are 2.5 million light-years between the Milky Way and Andromeda, so luckily our neighbor won't cover that distance anytime soon. It'll only happen in around 4 billion years. Such a collision of two galaxies might lead to real chaos for our descendants, if any of them are still living on Earth, that is. The two galaxies will slide past each other. Then they'll draw apart until the gravitational force starts pulling them back together. As they merge, they'll both lose their disk-like structure and form one big elliptical galaxy. It's already got the nickname Milkomeda. The Milky Way as we know it today won't exist anymore. Space is in constant motion, changing all the time. Scientists have a couple of possible scenarios of what might happen with the universe in the future. Number 1, the Big Rip. This theory claims that the universe will expand infinitely. At one point, the pull of the expansion will get stronger than the gravitational force keeping it all together. If this happens, it will tear apart galaxies, stars, black holes, and all other space bodies, including Earth. The universe will turn into a bunch of disconnected particles. Until about 5 billion years ago, the universe was expanding slowly because of its powerful gravitational pull. Then its growth sped up. Some experts say it happened because of the effects of dark energy. Dark energy is a mysterious force that makes up almost 70% of our universe. This force pushes it to expand faster rather than slowing it down. So, in the case of the Big Rip scenario, dark energy will win over gravity to the point where it will be able to rip apart individual atoms. Scenario number 2, the Big Crunch. There's a possibility the universe will get to the point where it'll stop expanding. Gravity will become a dominant force. It might even reverse the expansion of the universe. Then, the cosmos will start shrinking, making planets, stars, and even entire galaxies collide. In the end, the whole universe will collapse in on itself. Once everything compresses into one infinitely small point, which is something called the Big Crunch, the universe may start expanding once again. Theory number 3, the Big Freeze. Brr. In this scenario, entropy will grow until it reaches its maximum value. Entropy is basically the idea that everything in the universe declines into disorder at some point. Once entropy gets to its maximum, the heat in the system will be spread evenly. The universe will then disappear because there won't be any room for heat to exist. Any mechanical motion inside the universe will stop. The cosmos will be so empty and gas will be so thin that no new stars will be able to form or shine again. In such a cosmos, time is just an endless void. Nothing ever happens with planets, stars, or living beings. The entire universe is frozen, dark, and motionless because there's no energy that can make things start working again. Many, many billions of years after the last stars burn out and fade, black holes will send a message that the universe has come to an end. Black holes are areas with extremely strong gravitational pull, so powerful that nothing can escape it. They can be as massive as 100 suns. As for supermassive black holes, their mass can be greater than that of 1 billion suns. You can find such giant black holes at the center of most galaxies. Like everything else, black holes will experience the same end. But when their moment comes, they won't gently disappear into the night. Black holes will go away in enormous bursts of fireworks, lighting up the universe in the last moments of their existence. It will be the end of the entire era. Black holes usually survive by gobbling down the stars and gas that come close enough. Their gluttony is the main feature that gives them away. In most cases, there's an accretion disk around a black hole. That disk is made of all those materials and particles it's torn apart and is pulling inside, similar to when water swirls down a drain. As the materials and particles draw closer, they start to move faster and faster. This generates heat, which makes the accretion disk glow, which again gives away the black hole. Yep, black holes aren't that great at hide and seek. Things that cross a black hole's event horizon, which is also called the point of no return, are lost forever. But Stephen Hawking had a theory that you might be able to escape from a black hole. There are particles moving even in a vacuum. Let's say one particle has positive and one has negative energy. If they both come close to a black hole, there's a chance that one will fall into it while the other will escape. That means the black hole has radiated the particle away. And this particle has taken some of the black hole's mass with it, which is why the black hole may start shrinking. As it begins to evaporate, it loses its mass and slowly becomes smaller. More and more particles start leaving until all the energy that's left behind escapes all at once. In the final tenth of a second, there will be a giant flash of energy and light in a very, very small region of space,